Hello.
Good morning, ma'am. Good morning, sir. Ma'am, shall I
Good morning.
start?
Uh, Sir, can we start now?
Yeah, sorry. Actually, I was just busy in MTech and PGD final exams going on, and I was course
Okay.
director for that. So I was just
Okay.
busy.
Okay.
Just it is finished up, and now you can start.
No,
Please go
no
ahead.
issues. No issues, sir.
Yeah,
No issues.
I just
Sir, can we start
forgotten
now?
actually. Yes, yes. Please go ahead. I'm
Yes.
ready.
Priyanka, please start.
A very warm good morning to our eminent guest speaker, Dr. Shruti Ganga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, faculty members, students, and all the participants. I welcome you all on behalf of Suresh Gyan Vihar University on the 12th day of 21st day of winter school in geospatial science and technology. I hope you all have been enjoying this esoteric training program so far. Now, we are very delighted and eagerly looking forward to have you all involved in this quest of learning and embracing knowledge. So, with this, I would like to take a brief moment to introduce our guest speaker, Dr. Anil Kumar. He is scientist, engineer, SG, and head of Photogrammetry and Remote Sensing Department of Indian Institute of Remote Sensing, ISRO, Dehradun. He has completed his BTech degree in civil engineering from IET affiliated to University of Lucknow. He completed his ME degree and PhD in soft computing from IIT Roorkee and has guided many PhD theses, also guided several dissertation of MSc, MTech, BTech and postgraduate diploma courses. He passionately works with PhD scholars, masters, and graduate students for their research works and motivate them to adopt research oriented professional careers. He received Prisharthok Rama Prisharthi Award for contributing state of art fuzzy based algorithm for Earth observation data. His research interests are in the areas of soft computing based machine learning, deep learning for single data, and temporal multi sensor remote sensing data for specific class identification and mapping. He also works in areas of digital photogrammetry, GPS and GNSS, LIDAR, and many more. He has written books on fuzzy machine learning algorithm for remote sensing and image classification. On this note, I would like to invite Dr. Anil Kumar for taking forward today's program. Sir, you're most welcome.
Thank you. Again, I apologize. Actually, just I was busy conducting MTech and PGD Module 1 exam. And just it was finished. And after seeing the message of Dr. Shruti, I again remember that I have to take class. Anyways, I'm again thankful for considering me for this FDP program, which is going on as a winter school in geospatial science and technology as level 1 at Suresh Gyan Vihar University, Jaipur. I'm thankful to the management and Dr. Shruti Kanga, who has taken the permitted me and considered for this lecture and this talk. So as per the background of the participants, I have kept my topic to be image classification to specific crop mapping. And what I've came to know, maximum people are from geography background. So I've linked my talk towards agro geography studies as one of the field you study in geography. It can be undergraduate or postgraduate or in the research domain. So linking with this, my talk, I hope my PPT and voice is coming fine.
Yes,
Yes, sir.
yes.
Okay, thank you. So if you just link and think about agriculture geography, I'll just see one part, is specifically the crop. There we see the livestock also. But I'm talking about in agriculture geography, there is an emphasis on spatial distribution of crops and other agriculture activities. In time domain, people try to study and they go for further aspects of it. And here basically I'm talking about certain crops because if we try to go for examine the specific crops which are spatially distributed in an area per year basis and their cycle, what is the pattern of the crop going on yearly basis by the farmers. So there the emphasis is basically certain crops have very high concentration. So that is the one theme you try to study in one area you try to find out the very high concentration of specific crop, why it is, and in other area why there is low or insufficient concentration of other crops in other areas. So here the reason is for such spatial densities are examined by agriculture geographers. And the question comes that how to achieve. Otherwise, if you see with the remote sensing, we can go for mapping with or without crop agriculture fields as level 1. Level 1, we can say these are the fields with crop, these are the fields without crop. So that is level 1. But when we proceed further within agriculture field, we want to map specific crop fields. That means in a field there is specific crop going on in this year, and what is its yield, how it is affected with weather or other conditions. So that has to be studied. That means we are proceeding to level 2 classification, or within that field we are going to see the sowing stages of the fields. That means for a particular crop, which fields has been sown today and which will be sown after 5 days. So every some time interval, we want to monitor the sowing stages, we want to monitor the harvesting stages of the crop, or diseased crop field. When you talk about diseased crop fields, or the fields which are not healthy or which are affected with the natural some activity. So there you see at national level scheme, Pradhan Mantri Fasal Bima Yojana. So there they basically try to identify the specific fields of a crop which are affected due to flood or any other natural calamity, and they want to go for crop insurance. So the insurance person should basically initially check how much is the damage occurred in that crop in that particular field. So question comes how to achieve this. So that is the basic, my overall talk will be there, but I will talk the very basic also in this. So before going further, we can see the specific crop mapping and detection, its application we'll see in agriculture, in forestry, disaster or post-disaster study, in urban building, specific buildings which has been changed from open land to as a building. Can we map that? Then environmental conditions. There are some activities, human or natural, which are basically affecting our air quality. So here we can see vast applications, spatial distribution of crops, crop patterns, crop insurance, crop monitoring and yield estimation, urban specific vegetation buildings mapping. It can be building or it can be vegetation mapping. Species in forest, within forest, can we map the specific species present, post disaster damage studies, and air pollution sources studies. So here all these things I will talk about when we talk about the specific class mapping and detection. Before moving further, now I'll take a very basic to understand an image. As a book knowledge, we talk about the definition of image means pictorial representation. So that is bookish definition. It is 100% correct, no issues. But when you go for actual processing of the image, that definition does not fulfill. Image is basically, you see here, if you zoom it, you get a chessboard type of thing. And if you zoom further, you will see that it is basically grid and it has numbers. Actually, this has columns and rows. So this side you have columns and this side you have rows, and then you see each number are arranged in the form of row and column. So basically, image means it has digital numbers which are arranged in the matrix having rows and column. So this is the actual definition. If you are doing any processing, always see the image like this. Don't see the image what you see actually forest, water and other things. That is the final, that is top side. But if you see from internally, you see actually image is basically arrangement of numbers. And here also the real remote sensing image, that can be a sea or some ground. And if you zoom some portion, you see black and white image as a single band. And there, if you zoom further, you will see each basically pixel, which is smallest unit of the image, that is basically holding the digital number. And when you go for digital image processing, you are trying to modify these numbers. So actually, like in a body, if you see outside, you see a lot of beautiful physical faces, but actually that is flash. But inside you see the soul from which that body works in this world and for any creature. So same way here, the image is not from outside, from inside, basically the numbers which are creating and representing the different objects, their images. So we are trying to modify these numbers for image processing. You can see a multispectral image also. So here for 5-band image, each band has numbers arranged in the form of row and column. And if you take a smallest pixel, that is smallest unit of the image, and there here you will get 5 values, and they are represented in the form of matrix, 5 into 1 matrix. And this is called, basically technical term, feature vector. So feature vector in this case holding the 5 values at each pixel, it is basically feature vector. And here if you see each value, that is also coming feature vector 1, 2, 3, 4, 5, 6, like that. You have also to understand and focus the resolutions of the image. Specifically here I am showing the spectral and the spatial resolution, which is very, very important when you are going for a specific application. So here you can see the same object in spot 2.5 meter false color composite, and if you focus a stadium, you can see the different features at 2.5 meter pixel size. You can see the grassy area inside in that stadium, and you can see the spectator seats and so forth. But if you move to 10 meter as a panchromatic image is black and white, and you don't see so much information which is visible at 2.5 meter. Then if you see orthophoto at 0.5 meter pixel size, very high resolution image, here you can see that stadium very clearly. All the markings are much nicely visible. You can see the shadow of the spectator seats and so forth. But the same area you can see at 20 meter also as a multispectral image, and the stadium looks like this. Then you can say, what is the use of this at 20 meter? In this world, please keep the statement, anything present has its application. Nothing is not useful. You cannot say it is useless. Everything in this world is useful. So there is application at 20 meter, there is application at 10 meter, there is application at 2.5 meter, and there are applications for studying the objects at 0.5 meter. We have to see as per our application at which scale we are doing study and which type of image we should use. So it is very, very important at an initial stage to decide which type of remote sensing images we should use. Next, I'll just talk about in classification. This is very, very important exercise before we go for classification called separability analysis. So this separability analysis is done to see my 5 classes which I'm trying to map, how nicely they are separated between each other. So if I'm trying to study water, forest, settlement, agriculture. So here you can see in this diagram in feature space having just 2 bands, you can see each boundary are nicely separated. There is no any overlap, but it may happen that forest is coming closer to agriculture. So here if you see the green circle of forest is overlapping to some portion on agriculture. So this is a spectral overlap. So we can see which band combinations we should use in our data. Nowadays, if you see Landsat around 12 to 13 bands, in Sentinel-2 again you have 12 to 13 bands. So out of these 13 bands, if I'm extracting these 4 classes, which are the suitable bands to be known, to be used for classification? That means I don't have to use all the 13 bands. Can I use just 5 bands which can give maximum separation between these classes, and my computation time has been decreased? So that is the use of going for separability analysis on training data of all these classes which I'm looking to map and find out the subset of bands, not all the bands of the given image. I can go for subset of bands, and this has very strong application when I'm using temporal data. I will just talk about in the coming slides. This is a very basic thing. I can give you the real life example, and you can reply also in a cricket, because in India it is very, very famous cricket game. So how many players are there in cricket team? Anybody can speak, open the camera and speak. It is two-way communication. I don't like one-way communication. So I can see people are listening and they can reply my question. How many players are there in a cricket team? Very simple, basic question.
Sir, 11.
11. So do you think presently India team is in South Africa? There are 11 players in South Africa from India team side?
No, normally 11 players are in.
There is nothing normal or abnormal. My question was very straight.
About total,
how many
total
players?
player is about 16.
Yeah. So my straight question was no here and there. How many players in a cricket team? So if you see the team gone to Australia, there were around 20 players, maybe 18 players. From 18 on a particular day for a 2020 match or a 50 over match or your test match, they select the best 11 playing 11 playing players on that day for that match out of 18 players. So same way here, when you have a 12 band image, out of 12 band, how many bands you can select which can give you maximum separation, and other bands are redundant. Like in a 18 players, there can be 2 wicket keepers. So there is no use to use both to consider both the wicket keepers to play on that day. We want only one best wicket keeper. So that is the redundancy that can be reduced. So it reduces the redundancy in the bands and it gives the best subset of bands in the image. So discrimination of it is a discrimination technique that allows separation of major land cover categories. It allows separation of major land cover categories. I'm looking with a minimum error and a minimum number of bands. So it gives the minimum error in the classification and minimum number of bands we are selecting. So how we know? We know through this minimum number of bands through separability analysis. And in time domain, when we go for temporal data and crop cycle is suppose 6 months, in 6 months I have suppose 12 date data or 24 date data. Out of 24 date data, how many date data I should consider which can map my specific crop? So that I will see this application later. So here we are selecting bands because this is spectral domain. I can go in time domain. I have every 2 days one image. So I have suppose 20 images. Out of 20 images, what are the best date images I should select? So this also I can do through this separability analysis. Now coming to second, after separability analysis, we have selected the minimum number of bands which can give maximum separation between classes I am looking for. So after that, overall objective of digital image processing is to prepare thematic map, and that is done through digital image classification. Why digital? Because it does very fast and we can get the objects very clearly in a very short time from the given image. So objective of these operations is to replace the visual analysis. So in place of doing visual interpretation of the image data, we can quantify, quantitative techniques we can apply, and we can identify the different classes from a given image. So here you can see this is multispectral image of 5 band, and we are doing supervised or unsupervised, whatever classification has been done, we get the output, and each pixel is labeled to one class. This is water, 1 and 2 is vegetation, 3 is wetland, and 4 is soil. The very basic techniques what we study, like C means or K means, both are same, given different names. C or K means clusters we are looking for, because this is unsupervised classification. And in supervised, we have already studied like minimum distance classifier, Mahalanobis classifier, both are same. It is using only mean criteria. It is using mean as well as variance, covariance from the training data. So the distance becomes Mahalanobis distance. This was a Bengali person who has proposed this distance to use variance, covariance matrix also from the training data. The third classifier is a parallelepiped or box classifier. With the help of boxes, we create these boxes from the training data. using minimum and maximum criteria, or using mean and standard deviation. So using these two parameters, we create the boxes, and in that boxes, whichever pixels lying in that box, that pixel is labeled to that class because that box has a label. The fourth one is maximum likelihood classifier, where we generate the probability using the training data, and the probability should be maximum. Here, in the case of distances, the distance should be minimum between training data, between the mean parameter of a class to the unknown pixel. If the distance is minimum, that pixel is labeled to that class. So here, in the case of MLC, maximum likelihood classifier, the probability should be maximum, right? And then in the last, we go for classification accuracy. So here, these two classifiers which has been listed, they are also called as pixel based because they use the pixel information or color information. They use only pixel information, that is digital numbers, and they work. And they are also called parametric. Parametric means you apply the same classifier on n number of images, their behavior remains same because there is no free parameter. All parameters are fixed. So these classifiers are also called pixel based, parametric, and one more word I have missed, that is called statistical classifier. So they are also called statistical classifiers because these classifiers which are listed uses only the statistical parameters like your mean from the training data, standard deviation, plus minus, variance, covariance matrix, minimum, and maximum parameter from the given training data. In unsupervised, we don't provide any training data. Algorithm assumes you want to divide the pixels into how many clusters. So I can give cluster to be 4, and it works with number of iteration or the error. Error means the shift of the mean. So at every iteration, there is a shift of the mean. And if that shift is less than or equal to delta naught value given by the user, algorithm will stop. Otherwise, it will go on doing iterations. So any of these conditions should be true to stop the algorithm. Otherwise, it will go on refining the mean. Initially, the means for all the clusters are assumed because we don't have any ground truth information. So using this assumed mean, algorithm starts dividing the pixels into different clusters using the minimum distance criteria, and distance is calculated using the assumed mean of all the classes and the unknown pixel values. So as per the minimum distance, each pixel is given label to cluster 1, 2, 3, or 4 because here we don't have training data, so we have to assume the mean and we have to assume the cluster name as cluster 1, 2, 3, 4. So like that, it will go on doing dividing all the pixels in different clusters. So in each cluster, you will get some pixels. So using these pixels, again, you have to recalculate the mean of each cluster. Using the new mean, again, you have to divide all the pixels of the image. So this process goes on till any of this condition is true. One is number of iterations we have given. Suppose we have given number of iteration 10. And the error is the mean shift. If that mean shift is more than this delta naught value, so since these conditions are false, the algorithm will go on doing iterations. In supervised, we provide the training data. So that means we are providing the sample values of each class plus the label, class name. So in single iteration, using any of the criteria, whatever we select, minimum distance, Mahalanobis distance, parallel piped or box classifier, or maximum likelihood classifier called MLC, it divides the pixels into different classes. And since it has the labels from the training data, it gives the labels also. Question comes, what is the use of unsupervised classification? The use of unsupervised classification is if you get an image of an area, but you do not know about the area because you have not gone to the ground. So with the help of this given image, you can guess how many maximum classes you can map from this given image. So you can assume initially your number of clusters can be suppose 50, and you will get in the output 50 clusters. Now with some literature or some ground information later, you can try to see that some clusters are belonging to same class, so you can merge them, and what will happen, from 50 starting clusters you may reach to 30 clusters. So this will conclude that from this given image for this given area, you can extract around 30 classes. So unsupervised classification basically helps you to know, to get an idea that how many classes you can map from this given image for a given area. Sometimes if you have some pixels labeled with some undefined values, and you want to make the labels as per your choice, so that for that also you can run unsupervised classification, and you can change the labeling of these pixels. So these are few basic applications of unsupervised classification. For supervised classification application is to prepare the thematic map, and in this category, if you see, the maximum likelihood classification can give you the best result. But this also is following some constraint. It talks about your data should be normal distributed. Normal distributed means at each band, the data is following like this. So at each band by band, this is a constraint for MLC. It says it should be normal distributed. So here you can see the output of unsupervised. You may have whatever bands you have, and you are just applying the unsupervised algorithm. Here you have to take care for unsupervised algorithm. It should be very simplest one. Simplest algorithm you have to consider. Simplest means this algorithm is using only very simple variables like mean. Here C means or K means. C means cluster, and this C means cluster, and K also means as a cluster. So mean means it is using only mean parameter. So assuming mean parameter and refining the mean parameter in the distance equation is very easy. So we have to see for unsupervised, the algorithm is using the parameters, very simplest parameter. Here you see the output. This is your cluster 1, cluster 2, cluster 3, and cluster 4. So the label is missing, and the output is just a class 1, class 2, class 3, and class 4. For supervised, you are providing the training data, say for class water, agriculture, and rock. You can take the samples from the image itself. Once you have gone to the ground and you know that this area belongs to rock, this area belongs to agriculture, this area belongs to water, and you can apply these signatures from the image, and you go for supervised classification. That means the use of these samples are to calculate the statistical parameters of the algorithm. Like minimum distance algorithm uses the mean parameter. Mahalanobis distance uses the mean and variance covariance parameter. Parallelopiped or box classifier uses mean with standard deviation or minimum and maximum criteria. Any of these two criteria we can use in the parallelopiped classifier, and we can create the boxes, and in that box whatever pixels are there, they are labeled to that class. In the maximum likelihood classifier, if you see in the commercial tools, it uses mean and variance covariance matrix. But in the scientific paper, you can see the maximum likelihood classifier can be modified to use only mean or to use mean with variance covariance matrix. I'm not giving much mathematics, but I can just write about MLC equation. Probability is equal to 1 upon, don't get afraid, very simple equation I'm writing for probability for used for MLC. It is n by 2, and it is a mod of weighted matrix e to the power 0.5, and then xi minus xj transpose A inverse xi minus xj. So here, if you remember, initially I talked about image is a matrix and the smallest pixel is a feature vector. So here xi is a vector, unknown vector coming from unknown pixel, and xj is the vector coming from mean vector from the signature data. A inverse is a matrix, weighted matrix. It has three versions. It can be unit matrix, it can be variance covariance matrix, it can be diagonal variance covariance matrix. And this is again unknown vector, that is unknown pixel, and this is the mean vector from the training data. So in the commercial tool, you will see this matrix A is used like this as a variance covariance matrix, and it is using mean also. So it is basically using this is a Mahalanobis distance. If you consider this one, this is actually general distance equation. In the 12th class, we have studied as a Euclidean distance. So this becomes Euclidean distance when A inverse is a unit matrix, right? So it is a Euclidean distance. When we use this variance covariance, then this distance becomes Mahalanobis distance, and we can use diagonal variance covariance matrix also. Diagonal means we consider its diagonal elements and other elements are zero. So that is called diagonal variance covariance matrix. So if we in the commercial tool, it uses the basically mean from the training data. It also uses the variance covariance matrix, and it is using this distance as a Mahalanobis distance. But in the scientific domain, we can study this distance as a probability. To generate probability, we can use this as a unit matrix, or we can use Mahalanobis distance, or we can use diagonal variance covariance matrix. All these three forms we can get. We can get three type of basically distances, or three norms of distances, and we can get the probability accordingly. But in the commercial tool of ADAS and NV, they are using only the variance covariance norm. So this is the same way. If you see this minimum distance criteria and Mahalanobis distance, here we are generating the distance. We are generating the distance using Euclidean norm. Then it becomes unit matrix, that it becomes Euclidean distance. And if we are using this variance covariance also, then this becomes Mahalanobis distance. We can have diagonal variance covariance matrix also here. Then again, it is Mahalanobis distance, but the variance covariance matrix is diagonal variance covariance matrix. Next is confusion matrix or error matrix. So here, once we get the thematic map, we should have the accuracy assessment of that output. And for that, we require classified map. And we require a reference map. Reference map and classified map. So we can check the accuracy of this classified map using this reference map, or using these are training data or training samples. Sorry, testing samples. So here from the any sample if I take, and you have here classes, same classes on your reference map. So if you take one sample here, so same sample here, this is for class A, here also class A, and this is your class B, and this is your class C. So here, if you take one sample here, it is class A, so you can add here sample 1. Then next sample randomly or stratified random you can take here, and this is on class B, and here this is on class A. So class B is your classified, and reference is your class A. So here B and A sample will come here. Like this, you can go on creating this matrix. Here I've taken 136 samples. And like this, you can go on adding the samples. So you will get 3 by 3 matrix. Since I have taken 3 classes, this side reference data and this side thematic data. You can have a row total here. You can this total up this one, and this side you can have column total. So again, you can total this one. Now you can get so many parameters from this confusion matrix or error matrix. First parameter is user accuracy. User accuracy means how correctly your samples, testing samples are on the classified map. So for each class, you can get the accuracy. Like for class B, if you take how correctly samples on class B is 37. This is B for B. Here is B and here is B. And for total number of samples used for on the thematic map for testing its the thematic map output is 50. So it is, you have 37 by 50 multiplied by 100, it is 74. Then you can also get the error of commission. Error of commission means if you minus 100 with user accuracy, you will get 26. So it is 100 minus 74, it is 26. Producer accuracy means how correctly your testing samples are on the reference map. So here you can see for reference map for class B again, it is 37 are correctly identified on the reference map, and total samples used were 40. So it is 37 by 40 multiplied by 100, it is 93. And here you can get the error of omission. It is 100 minus 93, 7%. Then you can also get overall accuracy. So overall accuracy means diagonal sum, that is 35 plus 37. Oh, it's not writing properly. 35 plus 37 and plus 41. Divide by total number of samples is this one. If you go for row total sum and column total sum, you will get 136 multiplied by 100. So you will get overall accuracy. Then overall accuracy cannot represent truly because this does not consider the off diagonal elements in this error matrix. It is not considering these elements. So what you can do in the literature, you can follow the Kappa coefficient of CART, and this can give you much better representation of your accuracy in the form of 0 to 1. So here n is total number of samples, 136. Summation xkk is your diagonal sum, 35, 37 and 41. If you sum up, this will come here. Summation xk plus and x plus k is basically row, and you have to multiply the corresponding row and column total of a particular class. So here 39 into 50, 50 into 40 and 47 into 46, and if you sum up all this multiplication, you will get this value. Same n square, 136 square, and this again you can calculate your multiplication of corresponding class row and column total, 39 into 50 plus 50 into 40 plus 47 into 46. Then if you calculate this value here, you will get its value will be 0 to 1. This is not in percentage, but it is 0 to 1. Now moving further, and here it can be for overall accuracy or for Kappa coefficient. If your value in overall accuracy is more than 85, it is very good. For Kappa, it can be say 0.85. And if it is 60, or you can say 60 to 85, it is good. And below 60 is fair, and below 50 is poor. Same way here for 0.65 to 0.85 good, 50 to 0.5 to 0.65 is fair, and less than 0.5 is poor. So that way you can categorize your accuracy from as an overall accuracy or from the Kappa coefficient. Moving further towards machine learning. Now, if you take any classifier, that is basically coming under machine learning. Previously, you have subcategories of the classifier like statistical classifiers, decision tree classifiers like random forest or CART. Then you have statistical learning classifier like support vector machine. You have fuzzy classifiers, and you have learning classifiers like ANN, CNN, and so forth. But today, all these classifiers comes under single domain or single umbrella called machine learning. And here the subcategory of machine learning is deep learning, where you take the data to higher dimensionality. Then the word comes deep learning. So overall application, if you see, it is used for classification, labeling the pixels for different class as supervised or unsupervised. Second application is for prediction, for like for tomorrow the rain will occur or not, or what is the population of Jaipur, how and in which direction it will grow after 10 years interval. So next, very, very specific application, what I'm going to talk for machine learning is to map single class of interest. So here you can see you are mapping very general classes, water, vegetation, wetland, and soil. Within water, can we have subclasses? Within vegetation, can we have subclasses? And in that, can we map a single class of interest? Number of times, as a layman example, if you see, you are going to market to get the vegetables. So you're not interested in other shops. Your mind or your brain is scanning which shop is basically for vegetable shops. So other shops, you are not interested, you are skipping them. So here, same way, we are skipping the other classes from the image. We are interested only very specific class looking for. Second is when we go for single class mapping, specifically in the crop domain, there is very strong spectral overlap, because within crop means there is a wheat, there is mustard. And nowadays, if you see in Rajasthan, you see the blanket of mustard crop field, yellow color, and parallelly for some fields, you can see wheat and other classes. So all these classes are coming under Rabi category. And at particular date, if you take the image of particular date, other crop, other grasslands will give you same signature like mustard. If you are mapping mustard, other grasses may also give you same signature of mustard at any date. So it is very, very difficult to know which class is giving overlap, but at any date you will see some class of vegetation or crop is giving spectral similarity to the class of interest I'm looking, and that is called spectral overlap. So how to avoid this? We should go for temporal images. In the time domain, the question and the line I can tell you, when the spectral information stops to give you class of interest you are looking for, when the spectral information stops, after that the temporal information starts to map that class of interest, right? So here you can see, here we are seeing one field from 21st March to 30th of April, and same field you can see how it is changing. It is blue with, and again it is blue, now it is greenish, now it is pinkish, more pink, more red, and so forth. So here what we are trying to do in the time domain, we are taking indices values from these images and at specific date which is unique. So that uniqueness we can know by separability analysis. So here we are applying the separability analysis in the temporal data, and we are finding out what are the unique stages of the crop, so that at that date we should pick the images to map these classes. Second problem comes in the temporal data. From the same sensor, we don't get the temporal images. There is a cloud cover, specifically in the optical domain. From visible to NIR, there is a cloud sensitivity. So how to solve this problem? We have to go for multi-sensor. Multi-sensor means images from different satellites. We can use it. Yes. Here we don't have the data from same sensor. Here we don't have the data from same sensor. We can use it. So here you can see one application. We have done it also. We are using 2 images from Sentinel-2 at 10 meter. Third image here we are using from Landsat at 30 meter. And fourth image we are using from Sentinel-1. This is SAR image, totally different image. And here I make always one statement. As a real life learning, a boy from Tamil Nadu can marry a Punjabi girl. Both are from different cultures. They're everything brought in, they have been brought up in different cultures. Still they can marry, they can survive, and they can live their life happily. So same way here, these data sets can work and give you very important information, even though their characteristics are different. It can be as a pixel size or any other thing. They are quite different. Still they can work. Coming to see further issues like applying machine learning, we can see some issues like large memory is required for processing, large training data is required, generalization problem. And for a given pixel, which is a training pixel, we get a very good results. When it is an unknown pixel, we don't get good results. Like in a class, the student works very nicely for a known question. In the final exam or for the same paper, the student does not perform nicely because it is an unknown question for him. Question is coming from outside. So that is called generalization problem in the algorithm also. Then maximum parameters are free parameters. We have to optimize these parameters number of times, and it is time consuming. So for all these things, issues, if we focus for fuzzy based approaches for machine learning, they can give you maximum solutions for which we found some problems. They can handle the mixed pixels, because always there is a boundary, and boundary is represented by a pixel. Then you can have 2 classes like forest and water. How to deal these type of pixels? The class size is smaller than the pixel size. So here you have 2 classes, forest and water, and again you get a mixed pixel. Handling non-linearity, the separation between classes can be non-linear. So how to handle it? We can do by kernels. It can handle the noisy pixels, and this gives you the solution to map specific class. Any unwanted shops are noisy shops when you're in the market. Same way in the image, there are always unwanted classes, and these classes represented by pixels are noisy pixels. Capability to identify single class, and this capability gives you to map the single class of you're looking for. You're not looking, you don't bring all the items from the market, you just bring the market of your interest. So here, if you have only one class of interest, you can do that. And these algorithms require very small training data. We have already experimented, and that's our findings. And the latest one, what we have done it is they can handle the heterogeneity. One field, if you see for mustard, it is not uniform. There can be small variation due to non-uniform water applied, non-uniform fertilizer applied, non-uniform pesticides applied, there is some shadow of a tree. So all these factors can give you non-uniformity or heterogeneity within same field. So how to deal this? And this heterogeneity degrades your classification accuracy. That also we have done it. I hope my video and PPT is coming fine. I'm going a little faster also. If you can give me the feedback, I can take care. Hello?
No, sir. Fine, sir. Fine.
Okay, thank you.
Fine.
So moving further to try to understand, I've already talked about supervised and unsupervised classification. No need to discuss this one. I've already done it in the previous slides. But this is quite important to understand the hard classification and soft classification. So you have same image, 5-band image. Here you get one pixel as one label, but here in the same image, you don't get one label, one pixel. You get a fraction of value, and this is called membership value because it is a mixed pixel. And how to deal it? Maybe there are all the 4 classes present in that pixel. So it says 0.7, it belongs to water. 0.1 it belongs to vegetation, and 0.1 belongs to wetland, and 0.1 belongs to soil. This is called membership value, degree of belongingness. And these outputs are called fraction images because they are holding the fraction value. It is not holding one value. Here this class water is 1, this class for vegetation it is 1. So, but here it is less than 1. That's called fraction part of 1, and that is holded by these images. These are your outputs. So here in the soft output, you get multiple layers, one output for one class. This I've already explained the question of pure and mixed pixel. Here you can see all these pixels are representing grassland. So they are pure pixels. You can simply label grass, grass, grass. There is no doubt here. Here you can label water, and here you can label grass, grass, and grass. But the question comes what to label this one, because partially it is grass, partially it is water. So your mind get confused. And like this, when you have real life learning, when your ticket is booked, you say I'm going to Delhi. When ticket is not booked, you say I'm not going to Delhi. But when your ticket is in waiting, what is your question in your mind? You say 0.6, 60% I may go, 40% I will not go. And without knowing, you start using some technique of mathematics called fuzzy set theory. And by that you say 0.6 I will go and 0.4 I will not go. So same way here, because there is an incompleteness in the data, there is uncertainty in the ticket when it is waiting. So same way here, when there is more than one class, data is not complete. It is incomplete data. So you can say 0.7 is water and 0.3 is grass. So that way you can handle. But if you go for a hard classification, you will have overshoot and overestimation and underestimation. So this is overestimated complete pixels to be water. And if you say complete complete pixel is water, so water is overestimated and grassland is underestimated. So you are losing some information. Why to lose this information? And you can see nowadays real life example again, when you go for digital India. Previously, if you go for using paper notes and you don't have a change of 1 rupee, you have to pay 99 rupees Bata rate. So 1 rupee is lost by you or by the shopkeeper. But in the digital, you can directly pay 99.99 also. So up to that value, you can deal it. So same way here in the subpixel, you can deal up to the information present in the image. You can extract from this approach. So how to get these outputs? We can go for very simplest algorithm. What I've listed out is a fuzzy classifiers, and the very basic classifier in this is the fuzzy C-mean. It is C-means and it modified fuzzy. So here you get this is objective function of this, and if you go for partial derivative of this one with respect to membership value, and to minimize this function, you get this function. This gives you membership function with respect to distance. and distance is a function of unknown pixel with the mean parameter. Weight, m is a weight constant. Its value is more than 1, and it goes up to infinity. It controls the fuzziness in the data. When it is towards 1, it goes for hard output, and when it is towards infinity, it gives you fuzzy output. So, and from here you can get the membership value, but this follows the probability rule. So this algorithm cannot be used to map single class. But further, if you modify the same fuzzy with the FCM with this function, you get PCM, possibilistic C-mean classifier. And again, you go for partial derivative, you get this mu, the same like your FCM one. Second function, you get eta, which controls the shape and size of the class. And further, the final membership value, you get this one, which is a function of eta. And the advantage of using PCM is it can handle the noisy pixels, and it becomes capable to map single class of interest with minimum training data because it can handle the noisy data. Next is noise clustering, which is in literature as an unsupervised classifier, but we have used it as a supervised. Again, it has an extra objective function as a regression function here in this one. And if you go for partial derivative, you get this membership value for a class, and this is the membership value for the noisy pixels. The advantage of using noise NC classifier is it gives you quantification of the noisy pixels in your data, how many noisy pixels are present. And again, this classifier is useful to map single class of interest. Then in these two classifiers, it can be NC or PCM. You have to optimize one parameter called M. What should be the M value for your data, to take care that it matches the fuzziness present in the data. But if you come to MPCM, modified possibilistic C-mean classifier, again it is same objective function. This is extra added here, and again you get same like FCM one. This is FCM one, and if you move further, next step, it gives you eta, and final mu is here. Now this becomes independent with respect to M value. Also, it is independent with respect to parameter, and this can give you very high accuracy to map single class of interest. And again, it can handle the noisy pixels. It requires also minimum training data. Now I'm moving further to talk about the fraction images, the real fraction images. You can see the Ponta image. This is Asan Barrage, Asan River, Yamuna River, Gir River. This is west side of Dehradun near Ponta. You can see the fraction images for barren land. It is basically giving you membership value here 0 to 1. 1 means it is belonging to barren land. 0 tending to 0 means does not belong to barren land. Agriculture, here you can see the pockets where the agriculture crop is there, where the membership value is 1 for agriculture. You can see for dense forest, the values which are close to 1 is a dense forest. And here you can see the deep water. That means where the water is deep, membership value is 1. Where the water is shallow, membership value is not 1. So it is keeping the relative standing is maintained in the fraction outputs. In the hard output, the relative standing pixel to pixel is lost. You can see in the map, the complete polygon is talked about dense forest, but in the reality, if you see this complete polygon is not dense forest. Partially, you can see some patches where there is no hardly any tree. So in the fraction images, you can see the realistic output with respect to ground. Now I am going towards real application, focusing crop side, maybe for crop acreage mapping, which is an input to estimate the yield at a district or state level, specific crop stages mapping at the sowing and the harvesting, specific crop monitoring at the harvesting stage, and you can see this application talks about for crop insurance. This is quite latest outputs I am showing you. I have just focused to study in Jalore area. I came to know it is known for very unique crops like Castro crop. In Hindi is called Arandi, and in one more crop we have studied called Isabgol. So here you can see the example of specific crop acreage mapping, and in the Jalore district, and these are the fields from Sentinel-2 temporal images we have used from these dates from 22nd October 2022, which is showing emergence stage of the crop, 31st December flowering, 4th February seed formation, and 1st March, 16th March, and 26th March productivity stage, and 15th April maturity of this crop. 2021, quite latest one. So you can see these are the fields where in the Jalore district are the castor crops were there. And we have also gone for, in the same area, Isabgol, which is, this Jalore district is very, very famous for Isabgol crop. And last week I came to Nagaur area is also very well known for these crops. And we have gone for Isabgol to incorporate its stages from budding, pollination, ripening, seed maturity, and sun drying of this plant. So these are the field photographs we have taken. And you can see these fields which are having the Isabgol crop. So we can map these specific crops, and Isabgol is a medicinal crop, and we can estimate at district level or state level how much these crops are there area wise. And once we know the area, we can get the yield estimation also. So here at each year, if we do this mapping, and each year if we have this database, then we can take the difference of previous 2 years, and then we can see the crop pattern, the same crop, how it is grown in different fields, how it is changing. And then we can go for 10 years study, and then we can conclude how the pattern of this specific crop is going on at a particular district to state level mapping. And we have also experimented to use individual sample as mean approach. This I will talk about in the coming slides. This is a slight difference to using the samples in the any of the classifiers. So then you can see the example of specific crop monitoring. So you can see for Isabgol, we can map which fields harvested by 21st of March, which are the yellow color fields, and which are the fields got harvested on 24th. So within a 3 days difference, we can map the harvesting of the fields. And here you can see that we have tried to map the combination of Sentinel-2. The Sentinel-2 temporal information, if you use its 2A and 2B, around 5 days interval, we can get the images. But we are able to map with a just gap of 3 days. So that was only possible to use other images from CubeSat PlanetScope data called Dove satellites, which are around 130 satellites, and we can get every per day basis, we can get these images. So we have added these images of harvesting stages every 1 day basis in the Sentinel temporal data. Then we are able to map these fields around at a gap of 3 days. So every 3 days, we can map how this harvesting is going on, and then we can conclude some social aspects, why the harvesting was so early in these fields and why in some fields it was too late. It may be the seed was varying, or the farmer has done sowing late, or some any other cause that can be concluded later. Then you can see for again for Isabgol in different days at 21st March 2021, it's quite latest one in this year, in the last year only. Then 24th of March, the fields got harvested, and 27th. So every around 3 days interval, we are able to map these harvested fields of Isabgol in Jalore district. Then we have also done the study of sunflower, specifically in Kurukshetra, a large area. The sunflower crop is grown in Shabad area. Using the temporal images for sunflower crop, again you can see we have taken its crop cycle starts from February, but we have taken images from 21st March to 30th of April after optimizing these temporal images. And you can see we have also given one input to NDVI, or any indices rather, called CBSI. Always if you apply any indices, you should know its bands in the formula and where are these bands in my images. So in the images, you should know where is my red band and where is my NIR band if you're applying for NDVI. Or if you're applying any other indices, again, you should know these bands present in your data. So that means you require expertise. You should be PG diploma or MTech, so that you can find out, you can read these bands from your given image. But CBSI, class-based sensor independent. Sensor independent, it is not asking your data belonging to which sensor. You just open the image in a viewer and give a click. You open the image and give a click. Yeah, this is my field. If you give a click and you select the formula of NDVI, NDVI talks about band 1 minus band 2 divided by band 1 plus band 2. So it will tell band 1 should be which band and band 2 should be which band. Class based, you are just showing this is my class, and you get a click, and by that click it will take the very appropriate bands, and it also takes care that band should give you maximum enhancement to that class. So this is a new approach what we have done, proposed, and a lot of publications has been done by our team, and you can see in the net also. In the sunflower, you can see again it is an example of specific crop monitoring. At the sowing stage, we can map the early sown fields in the red color, middle sown field in the green color, and the blue color as a late sown fields in the sunflower. Using the chlorophyll index CI approach, again the temporal data. We have gone for paddy burn fields identification, the stubble burning, which is very common in the Punjab and Haryana regions. Specifically, we have taken the Patiala as a test site, and last 2 years we have done this study, and at date wise we can see the monitoring of these burn paddy fields. What we have done, we have taken one image pre-burning time and one image just after burning. So we have just taken two images. One is pre-burning stage image, and second is just after burning. And we have the ground truth samples which fields burned at that particular date. So using these temporal data, we can map the field level burning at particular date, like 20th of October 2018, then 25th of October, then 30th of October, then 9th of November, and then 19th of November. Every say 5 to 10 days interval, we can map the field level burning, we can identify. And that time we have used Sentinel-2 data. Nowadays, if we use the Dove satellites PlantScope data, which is at every per day basis, hopefully we can map this burning at daily basis also. So you can see in this animation, date wise, at the field level burning happened in the surroundings of Patiala region. And you can see for the large coverage, we have processed the large images. Also, again, with the date wise, you can see the burning is happening. And the government can specifically issue some order. They can ask them to stop at the field level, because they know the field has been identified. Then they can know this field belongs to which farmer, and they can ask them to stop these activities. Because in October, November, this burning takes place, and this really gives you contribute a lot of pollution, air pollution for Delhi and the surroundings area. Then we have gone for paddy fields transplanted at specific dates, and we have done the studies in Haryana districts here, Ambala, Pehwa, Ladwa, Kurukshetra, and Rador areas. Here also you can see this is the example of multi-sensor approach. So here you can see again it's a specific crop monitoring activity. And here we have used Sentinel-2A data, 2A and 2B, and then Landsat, which is at 30 meter, Landsat and Sentinel-2 is 10 meter, then Sentinel-1, which is at SAR image. So here these two images are basically pre-transplantation stage, and this is the date of transplantation, and this is the post-transplantation date. So here we have used 4-day data, and we got the transplanted fields, but we got one more problem. A dry river was mapped. Why? Because the transplanted fields were dry, then with water transplanted, and then after transplanted. Same situation was happening in the river also. It was dry, it was wet due to rain, there was small grasses and further grassland. So it was giving same signature, and we are not able to separate this dry canal when we map the transplanted paddy fields. But what we have done, we have added one more image in the same database, 6th March image, and this has given the information of the fields which were wheat fields, which is quite homogeneous in Haryana area. And then we were able to remove this dry canal from the database. And here we have used a deep learning CNN model, and these are the optimization parameters we have used for accuracy with epoch and loss with epoch. And this is the model structure of CNN. And then we have experimented to add LSTM also in CNN, and tried to see its results. It was not so much good when in comparison to just when we have used CNN. And this is the CNN LSTM structure. And here you can see these are LSTM layer 1 and LSTM layer 2. We have experimented how its effect will come up. And we have also gone for paddy fields using fuzzy models, and try to map the paddy fields at specific date. And also, if you see in the paddy fields, once it goes in the North India, everywhere you see water. The fields are having filled with water, and the natural water bodies are also filled with water. It can be lake, canal, river. So here we are able to map the paddy fields transplanted on 24th of June, on 10th of July, and also we are able to we are able to separate these fields with the water bodies. Water bodies can be ponds, can be canal, or some river, or so forth. I've just talked about heterogeneity, how this is dealt. In a field, if you see, it is not quite uniform because water is not applied uniformly in the water in that field. The fertilizer is not applied uniformly, and there can be some shadow, or the pesticides is not applied uniformly. So due to that, the field is not uniform, and this is not considered in any of the machine learning algorithms which we are using, because they are using statistical parameter. And this you can see again the real life learning. In the class, teacher says I have taught a subject, and in my subject the average passing marks was 80%. But if you see the real marks in the class, the marks are going from 60% to 99%. Why it is so? The 80% is not giving the reality of the class, because there in the class marks are going from 60 to 99%. So the teacher has done averaging of the marks, and this average does not give you the realistic picture with respect to ground. Like you can really feel in the COVID case, government says death is 1%, but in the particular family who has faced 4 family death members, so that is really painful. That is not coming out with 1%. So the average what we use, it is good as a statistical parameter, but when we try to use in the algorithm to get the real ground information, then this cannot give you the realistic picture. And you can see the heterogeneity within forest. It is not uniform pixels. Within dry field, it is not uniform. Somewhere it is dry, somewhere it is moist, somewhere it is a little dry grass. So there is a small heterogeneity, and you have to map this complete field as a one field, which cannot come up because within that field there is a variation. So here, generally what we do in the conventional classifiers, we use the mean parameter, but you have these many samples. So these samples representation has gone as a mean, and then the output will not be more realistic. In place of that, if you use these samples as a mean, this can give you more realistic output. So we have tried the same thing. Individual sample has been treated like a mean. Like in a company, you have one boss and 9 employees. So the objective of employees is to do the projects. Objective of boss is to get the projects. So one boss can think up to limited approach to get the projects. So virtually what we can do in a company, all the 10 people are boss virtually, and all the 10 people are employees. So in that case, when there are virtually 10 bosses, so 10 times they can think to get the project, and 10 times they can think to do the project. So that way, virtually you can increase the capability of the company. Same way here, we have used each sample as mean. So that sample is not eliminated. So here you can see within your area in Banasthali, because my daughter study and I went there once, and I go a number of times, but once in the winter time when I've seen it was pink blanket, yellow blanket with the mustard fields, and this was quite fascinated. I thought to use them as a ground truth and to study the algorithm. Just I walked. So this is the campus, Banasthali campus. This is the airport they have. And this is the main road. Just I walked along this road, and I've taken a lot of samples for mustard, wheat crop going on in the winter time. And we have experimented with these Sentinel-2 temporal images to map these crops using individual sample approach or using statistical approach. So here you can see when I'm using the individual sample approach, the fields are quite uniform. And when I've used the statistical approach, the fields were not so much uniform. You can see within the same field, it was not uniformly mapped, even though it was a actual mustard field. Same way for the grasslands within the campus and the outside campus, they have the cricket ground, which came very nicely. Still you can see white dot, but here it is perfectly mapped, and the nearby one more field, and this parade ground was also mapped, and outside the grasslands was not picked up here when we have used mean approach as a statistical parameter. But when we have used the individual sample, you can see these grasslands were also mapped near airport very nicely. And same for the wheat fields. So these were the actual ground fields, came very nicely. But when we have used statistical parameter, the same fields were not mapped properly. Then we are also trying to process the UAV images for cauliflower fields, and we want to map the wheat fields, how much is the weed present, and so that some pesticides can be used for it. And here we are able to got some success. Still we can see some spectral overlap. The center part of the cauliflower is matching with the weeds present in the field. So here we are trying to get some solution to avoid it. This spectral overlap should also not be there. We have done for sugarcane crop. Within sugarcane, you get plant or ratoon. Plant is the first year crop. Ratoon is the ratoon is the second or third year crop. So we are able to distinguish these two crops, and the sugarcane mills are interested how much is plant and how much is ratoon, because ratoon comes first, which is just of 6 to 7 months crop, and the plant takes around 9 to 10 months crop. So they want to see how much is ratoon and how much is plant, and when the ratoon will be coming to the mill. So we can distinguish within sugarcane, ratoon and plant. Within, for world view, you can see at 2 meter, we are able to map the harvesting wheat fields. And at 2 meter, you can see very detailed field boundaries. And you can see there are some wheat fields and some are not wheat fields. And you can see how these has been mapped. These are the wheat fields, very nicely mapped. And these are not the wheat fields. And you can easily distinguish. And here just we have used 2 date image, 3rd March 2010 and 12th April 2010. We have experimented long back using again for wheat fields in Udham Singh Nagar, and using the images from 21st November to 11th March. This is basically Rabi crop cycle. Gone for TVI and got the output. Here you can see all these white patches are your wheat fields as a fraction images. We have also experimented for cotton crop in Aurangabad. The cotton crop is basically from May to March, and from October onwards, the flowering and the budding of that cotton bulbs takes place, and we are able to map the cotton fields. We have also experimented for deciduous fields of the Shivalik Hills in Dehradun, deciduous forest areas, and that also has been mapped using the temporal data. Here we have long back experimented to merge the Formoset 10 meter image with Landsat 30 meter image. And this was done at east of Haridwar to map the wheat, to map the rice fields and separate the water bodies, that is the Ganga River and the canals in the area. Now coming to crop remote sensing, for this remote sensing information for crop insurance. Here you can see in the time domain, this is one agriculture crop. So one crop is healthy, it is basically growing further, it is from germination to further growth is taking place, flowering and so forth. But some pixels you can see which are affected due to disease or some flooded effect is there. So here these pixels are affected and their health has been dropped. So if we see their temporal indices here for healthy pixels are nicely coming up as they should be. But the affected crop due to flood or some other incidents, their indices has been dropped. This profile from this point onward has been dropped. So if I take this signature, I can map these fields which are affected due to natural calamity. And then company can know how much is the area, and they can also estimate how much was the drop in the yield in that crop fields, or the yield has been damaged, and then they can go for crop insurance once they know the actual area which has been affected. So the application is again same. We have to just summarize that how many fields are affected. So if I take the signature of the affected fields, if I take this signature in the time domain, I can map these fields very easily wherever it is present in the image. And just few weeks back, I've taken some support of geography people in the Nagaur district, maybe district or city near to Nagaur. There's one city called Merta city between Nagaur and Ajmer, and here we have basically seen very unique crops. Again, Isabgol from Jalore to this one also. Then cumin, again spices, basically we got it, cumin fields. Then here gram chana or chickpea crop, and then sauf and fennel crop fields we got it. Then in the trees, khejri is very common fodder tree which is used, and it is getting leaf sheds in summer, and it's very covered by leaves in the winter, I think. And then the neem tree, which is very common from Rajasthan to UP. And these crops we are going to study and seeing the further research, how the algorithm behaves, how the data integration takes place with these crops. This for Taramira is basically again similar crop to your mustard crop, and they are quite similar. Can we distinguish mustard with Taramira, and can we map these fields and how the algorithm is behaving? Just we have collected the geotagged fields from these areas, like for wheat also we have done it, and for Isabgol also. Then can we map these and go for further study? This we have to do later. And also I'm working for lavender, which is basically aroma crop in Jammu and Kashmir in Doda district, and we got the field photographs as well as geotagged fields. in this area, and we'll try to study where these field size very, very small, and we have to give some answers. Can we map and can we do some study on these areas also? Next is in the urban. If we move further, we have experimented within Dehradun last year in the second COVID time. That can we generally we go for built-up change detection. We just say in 5 years how much the built-up has changed in a city. But can we map the building footprint change? That means there was an open land, and that open land has been converted to built-up area. So can we map that change from open area to built-up, and that to the building footprint? The answer was yes. Here we have again used the 2 date images, like one for October 2013 Landsat 8 image we got it, which is at 30 meter. There some fields were open fields, and then in October 2019 Sentinel 2 image we got, and that time in the same field building came up, and we have applied fuzzy based MPCM classifier. I hope my voice and slides are fine.
Yes,
sir, everything is coming properly.
A few more slides I will just talk. I hope I'm not taking much time. Still 11:22. So here, what we have done, we have taken a few sites for training and few sites for testing. So one site we have taken for training in near Baruwala, and here you can see this patch. Here we can see on the Google Earth very clearly. It was an open space in 2013, and in 19 very large size building came up, and 4 sites we have taken to study the output, like at main Sabji Mandi of Dehradun, ISBT of Dehradun, Doon University. Some buildings came up in this campus which was not there previously, and near Kalidas Road at our campus site, new buildings came up in the last 6 years. So we have studied within 6 years change, and can we map the building footprint, transition building footprints from open space to building footprints. So here, if you see one output on the test site near our campus in Kalidas Road, and we have compared with NDVI difference. So here, some buildings, if you try to see on the Google Earth, that's an open land, and the new apartment came up as a Shivalik apartment here, this one, Shivalik apartment. And within our campus, we can see there were some new buildings came up, like Golden Jubilee Hostel and Meridian Heights, just at the gate of IRS campus, new one more apartment, and then Vikram Sarabhai Hostel. So here, when we go for NDVI difference, the Shivalik apartment is just showing the NDVI difference. It is not telling it is a building. And same way, when we go for conventional post classification change detection, we can see the change, but we cannot make it out the building footprint. But here, when we see, we can easily map the Shivalik apartments here. A. B was Vikram Sarabhai Hostel within our campus. New boys hostel came up. Then Golden Jubilee Hostel here. That was your C. Then D is a new stand-alone bungalow at the gate of IRS campus. They have changed its roof as a concrete to tin roof. On the concrete, they have put a tin surface. And at the main turn of the Kalidas Road, the Meridian height, we can easily map. Then in the testing, in the training site itself, if you see in Google Earth, there is a large vegetation in this same field, and now you can see large number of buildings, and we are able to map the building size level up to. In the NDVI difference, we just see one patch which has changed in the NDVI mode. In the post classification, we can see the changes came up, but we cannot see the information up to the building level. But here we were able to see the building level change came up in this area, which was our training site field. Then at the Doon University, which is an old university, which is of course new university, but it was now completing around 20 years back. So here few buildings came up in this campus which was able to map, which was not done through NDVI difference or just with post classification change detection. Then within Sabji Mandi, the main Sabji Mandi of Dehradun, the large number of new apartments came up. And with this technique, we are able to map these patches of apartments which came up at the surrounding of Sabji Mandi. So this was the main Sabji Mandi area, and the surrounding of it, lot of apartments came up, which was able to map. And that ISBT, which is old now, but at the surrounding of it, lot of government departments and malls has came up, which was able to map with this technique very nicely. Here we got some limitation because the first image was at 30 meters. That time we did not got Sentinel was not there. But today, if you see, if both the images were 10 meter, the results was much better one. Here you can see for post-disaster also long back we have done for Bhuj study, Bhuj earthquake, which was came on 21st January 2021. 2001 at the early morning by 9 a.m. And a lot of this area got liquefaction activity. Liquefaction is shaking of the sand dune, and the water surface comes out from the ground. So, and can we map these areas and we can separate the existing water bodies? Answer was yes. Here you can see the all red patches are your liquefaction areas, and you can see the demarcation with the existing water bodies. Also, we have experimented with different classifiers like PCM or NC classifiers, and we have checked with respect to different data sets. It can be Landsat 7 or IRS-1D data sets, and we are able to map. Then in Balakot in 2005 and 6, very heavy earthquake came up. Large number of patches were affected due to landslides, and Balakot city was damaged to be around 80%. So we are able to map. Basically, if you see the landslides, the built-up area and the damage built-up area, they will give you same signature in a single image. So here we have taken pre and post date image after the earthquake, and we are able to map the landslides patches. We are able to map the damage area, 80% for the Balakot, and we are able to map say 20% non-damage area. And the accuracy we got luckily for this area, we did not went to ground, but we got the ICONOS image which was at 1 meter, and we are able to map actual these damages from that image, and we can correlate our outputs with that images. In the detection, specifically for the deep learning, we are able to map the trees to be detected. We have done it with good accuracy, and up to we can get the point map also, and we can get the coordinates also with these trees which is mapped. And then again for environmental pollution, these brick links which are partially unauthorized activity, can we map these brick links up to shape and size also? Yes. We are able to map we can detect these brick links, we can map as a point map, and we can also identify with respect to shape. Some are as a elliptical shape, some are rectangular shape, some are circular. So can we map this shape wise? Yes. And can we map as a active and non-active brick links? That was also possible with these images. Here we have used the Google Earth images, and which was giving sufficient information for detection purpose. And we can get the coordinates again for these brick links. And all these temporal activities what I have shown you for processing, we do with our own developed tool, which is not possible with the commercial tool. And here you can see the main GUI for the temporal data processing. And the advantage here is just you require 4 steps. You have to load the one image in the front end, and other images you can load from here. So other images will not be visible, but the front image will be visible, and the front image we consider so that the field wherever you have the ground truth, you can see that field very nicely. You can see that field very nicely. And then on that field, you have to, you can load other images, then you can give a click on that area. So by that click, it does 2 things. One is it creates the indices for all the temporal images loaded in this tool. Second is the same click also works as a training seed point, starting of the training. So using that click, it does the training also. And it takes the temporal indices layers to process further. And you can initially you can decide some of the parameters here before you start the working with this tool. You want single click for the training data, or you want to go for manually the coordinates you want to enter. You want to take the indices like a simple ratio or NDVI formula or TVI or so forth. You again, this single click or multiple clicks you want to take. Then for training data, you want to go for single samples, or you want to go for large number of samples automatically. If you want to go for automatically large number of samples, you can create a window of 20 by 20. So both the sides from a single click, -20, +20, and here -20 and +20. And this will create a box within this window. It will search all the pixels which are similar pixels to the seed pixel. And these pixels are considered for training data. In place of collecting the data for training manually, you can go for region growing method. So we have implemented it, and you can go for thresholding criteria to considering all these pixels to be training data. You can decide what should be the threshold. So these pixels should be more than giving the threshold more than that value. And you can say region growing on and off, and you can go for any algorithm for region growing using similarity criteria or dissimilarity criteria. And after that, you can save the outputs, and then you can select the large number of these classifiers I told you initially. They are capable to map single class. It can be for PCM, it can be for MPCM, or noisy or noise clustering with or without entropy, and you can take large number of distances. Today, if you see in the literature, it is not only equivalent distance, which we there in the commercial tool, but in the literature, you can see different distances, equivalent distance, Mahalanobis, Canberra, normalized square equivalent distance, and so forth, cross correlation, and so forth, Mahalanobis distance with classifier, and so forth. So these are the distances you can go for, and then you can get the output. So automatically within just 4 steps, you can get the output. And last year we got worked for publishing our book on fuzzy machine learning algorithms for remote sensing image classification under CRC Press. And now I got a flavor to writing book. I'm going for 2 more books. One is midway on deep learning, classification to deep learning for remote sensing data. And the second book I thought just is getting started for application of temporal data in agrogeography. So with this, I stop you and I stop myself, and I thank you all for listening me. Now, if you have any questions, query, let me know. I think I went a little faster. Sorry for that again. Sometimes my flow changes, but I can take up your doubts or queries now in the coming.
Thank you, sir. Good morning, sir. My name is Dr. Sarvan Kumar, and I am University Coordinator of IRSS Outreach Program in Purvanchal University.
Program. Yeah.
Yes, sir. So my question is that can we map the area of burning on daily basis for Punjab and Haryana region during crop residue burning, and which satellites can be used for the data acquisition? Thank you,
okay. Yeah, for this, with me, 2 MTech students worked in 2018. They completed one completed in 2019 and one completed in 2020. So you can see they have published the papers also. If you just type in Google my name and paddy burned fields, you can get a lot of papers. That time, if you see, we were having only Sentinel data with us, right? And if you take Sentinel-2 A and B combination data, you can get the images every 5 days. And you can see maybe some date was having cloud cover in October, November sometimes. So you can see these dates, what we have mapped, which are at an interval of 5 days or sometimes 10 days. So we were able to map that time 5 to 10 days interval, the burning pad, this stubble burning. But today, what we have explored, and we are doing it very nicely, this CubeSat Dove satellite, and this data is available every 1 day basis. And I have visited in the field. I don't have added here the field photographs, but we have visited in the field, and I have seen daily basis the burning starts from first week of October, and it goes by around the 20th of November, around 1.5 months. So daily basis in the evening hours, because the daily basis in the evening hours, the dry biomass is totally dry. The moisture has been gone off, and then in the evening they can burn, and the one field just take 1 hour to be burned, and immediately they do plowing, so that any government people cannot catch, and they can say we have not done burning, and all the ash has been mixed with the field. But still, if you can get the image next day, you can map it that next day, the field which was burned in the evening hours. So today, if you see the CubeSat satellite, which is available for research point of view, freely available, you can use this data of this 5,000 square kilometer data, which is freely available. You can download and you can use it, and you can map at daily basis today. I can tell you, because we have done it for Isabgol, and I've shown you that time in the Isabgol is a very gradual harvesting takes place. What we have find it out, if the harvesting is happening today and tomorrow, and within 1 day difference, maybe this difference we cannot make it out. So we have taken a difference of 3 days, and we are able to map every 3 days the field harvested fields. And still, because this Jalore study we have done, I did not went to field. Again, I am thankful to all the geographers who was helping me to get the remotely ground truth data. I have helped them through video calls to collect the data for me. And still if I have taken this information up to very close every 1 day basis. Hopefully in the future we can map the crops also every 1 day basis for harvesting or the sowing stage information. But for the burnt paddy fields, I can tell you, you can use it for 1 day basis, because that is very drastic change. Within one field it was dry biomass in the field, and next day you see it is black. So it is changing from dry biomass to black, and you can map it. And this Dove satellite is available, which you can use it for a daily basis.
Thank you, sir. Thank you, sir. I will contact you for that or papers. Okay.
Yeah, even for J&K site, we got 2 geographers faculties, and they helped me, and I hope I can work with them in the future for processing the data for lavender, which is an aroma crop. And again, one more geographer from Merita, that's Merta city near Nagaur and Ajmer. Just 2 weeks back, I was with him online, and he has given me the ground truth geotagged samples of large number of spices, which I was thinking 3 years back down the line in Rajasthan, a lot of spices are grown. And today I got the samples of cumin and soft fennel. So I'm thankful to a large number of geographers, those who are supporting to conduct the research. Yeah. Any other questions?
Sir, good morning.
Yeah.
Sir, can we find the Saraswati river which is dried?
Yeah. In Allahabad.
No, sir. In Haryana.
But वो वहाँ से flow करके meet तो त्रिवेणी में मिलता है ना वो शायद.
हाँ, yes sir, yes sir.
So
yes.
when I was doing masters, from IIT Roorkee, he was now my PhD supervisor. That time he was not. So in his lecture, I still remember that he told that in Allahabad you can see, because what may happen that you may see there Ganga with water, and you can see with totally water signature, and for Yamuna also you can see the water signature. Right, here also water and here also water. Both are this is Ganga and this is your Yamuna, right? But if you see the Saraswati, what they say is it is flowing underground. So definitely the moisture will come out to the surface, because if there is a clay content, of course, in the soil there is a clay content, and the clay gives you more capillary effect. And due to the capillary effect, this area will be more moist, and the linear feature will come up. And that time he told, in the image we can see some moist impression on Triveni region. I have not done that study, but his lecture is there in my mind. The moment you told, I just recalled his wordings. And if you're talking about the same that Saraswati is flowing in Haryana also, and if you have some study, if you have some area where you have some doubt that there is some river, the river means it should give you a straight rectangular patch like of thing. Linear feature should be there, and which should be moist. So what you can do, that you can take some dry river which is moist, not dry fully, it is partially moist, and you apply this signature and try to map. Or where if you see this area itself, it's a moist, and you take signature and try to map and see, are you getting this linear feature, irregular linear feature? If it is coming, then you can conclude, yes, it can be a river, and you can label it if it is Saraswati, if it is connecting to up to Triveni. Then later on you can do ground truth, like you can do digging part. Maybe after 2 meters you may get sufficient water and these pockets. If you do digging every say 2 meter interval, hope so you may get water. Or maybe after 40 meters, whatever the depth is, at different pockets if you do digging. And if you get more or less same water level, then you can conclude there is a water flow underground at some same level, and you can conclude it is like a linear feature, because aquifer can be generally rectangular patch or irregular polygon, but this is a linear feature. Then you can conclude, yes, it is a river. And by remote sensing, then it supports you to cover larger area. This water body type of things you can do by Sentinel. Full image you can take, which is covering kilometers, and you can do the study. With of course, you can. In this case, you can do single date also. You can take multiple date also. No problem. Because for water case, you don't require temporal data, but in this case, you can experiment with temporal also and with single date also.
Okay, sir.
And hopefully, if you do after rains, Just after rains, because just after rains means everywhere water increases. So here the water, the moist signature will be more prominent here. Or maybe just before rains or after rains. If you do two studies, then you can conclude a lot of things.
Okay.
Any other questions?
Sir, I have a question. Yes, sir. This is Varun this side, sir. Sir, which method can be used for, or you can say which method is very much suitable for sub-pixel level classification?
Okay. Today, I just missed one more thing, that today you can use any classifier for mixed pixel. Mixed pixel means you want to go for sub-pixel classification or soft computing rather. जब झगड़ा होता है तो प्यार से काम करना पड़ता है, तो दोनों को सेपरेट करना. आप भी उनके साथ झगड़ेंगे तो आप भी तीन पार्टी हो जाएंगे which is fighting. So softly you have to separate them. If you keep them far a distance, they will not fight. So same way here, the mixing is taking place. Why the fight takes place? There is a mixing. So mixing means in the case of pixel, like a boundary, pixel is representing as a boundary. So you have two classes. You may have two or more than two classes. So there is a mixed pixel, right? Or one class is smaller. The class compatibility with the pixel size is not meeting, and this always happens, and you get the mixed pixels. So how to deal it? You can go for soft classification. Today, any classifier, you can use it for sub-pixel classification. If you see in Envy, they have implemented any of these classifiers starting with MLC, decision tree, ANN, or support vector machine as soft and out or hard. When you generate output in Envy as a classified output, it talks about classified output, and it also talks about rule images. Rule images are nothing in Envy, are the fraction images. So today, any classifier, you can use it to handle the mixed pixel. But more dedicated, if you see in the theory, the fuzzy classifiers are actually designed to tackle the incomplete data, and that is your mixed pixel.
Okay. Sir, but there is a very important role of spectral information when we are talking about the sub-pixel level classification. So is it useful to use more number of bands, like the images having more number of bands with respect to the images with less number of bands?
So in a cricket team, if now I don't know who is the captain, if you take the previous captain, Virat Kohli, if he takes all the 11 players opener, so can you can get the good score?
Okay, sir.
You cannot just increasing the bands. Please try to understand. I talked about separability analysis. Separability analysis means if you have 20 players, the coach is the role he's playing as separability, which takes care each player is unique. Each player should be unique, right? And in the cricket, the team wins if you have all the players as all-rounder. So all-rounder means it can do a lot of activity. So that way, the uniqueness of the player is there. Same way here, each band should be unique. There should be not redundant bands. If you just adding the number of bands does not mean you can get the good accuracy. Accuracy will come up. I can just introduce one blank slide. It is easy for me. If you see in the, suppose if you take two band data, B1 and B2, it is easy for me to plot. I cannot plot more than two.
Yes,
so if you take, suppose two bands, I just talk about these are pixels for water, and these are the pixels for agriculture, water, and forest. So here in these band combinations, B1 and B2, you can see good separation. You can draw a line. But if you take band combination B1 and B3, what is happening here? Agriculture and forest. Now here you can see few pixels are spectrally overlapping. So
yes, sir.
If you take band 3 with band 3, that means band 3 is giving some spectral overlap between forest and agriculture. So band 3 is not good. I don't know what is the band, just I've given you example.
Okay, sir.
So you have to consider, and how to consider separability tells, if you take one date image and it is suppose 10 band or 20 band, whatever it is, it tells out of 20 bands, which bands are suitable to map class of interest you are looking for. You are looking class, suppose agriculture, water, forest, settlement, barren land, orchards, 1, 2, 3, 6 classes you are looking. Then it will tell separability out of 20 bands, which bands are giving you maximum separation. कितना maximum हो सकता है, कोई जरूरी नहीं कि वो sufficient हो, but still it is giving maximum separation.
So it means
तो वो कौन सी bands हैं 20 में से वो बताएगा. वो 7 bands भी हो सकती हैं, कौन सी 7 bands हैं, या 10 bands हो सकती है, या 20 की 20 भी हो सकती हैं. Maximum you can go up to 20.
Okay, sir. It means that we have to perform interband separability analysis for each band.
जब आप सिग्नेचर डाटा जनरेट करते हैं ADAS में, तो वहां पे आप देखिएगा सिग्नेचर एडिटर में एक सेपरेबिलिटी एनालिसिस बटन है.
Yes, sir.
तो वो सेपरेबिलिटी का वही ऑप्शन है कि आपने यहाँ पे क्लास का सिग्नेचर डाटा लोड कर दिया, एग्रीकल्चर, वाटर, फॉरेस्ट, यहाँ पे उसने आपने लोड कर दिया सारी 6 की 6. सेपरेबिलिटी एनालिसिस करिए, फिर वो पूछेगा कि आपको कितनी बैंड सिलेक्ट करनी है. आपने एक ही बैंड ऑप्शन किया, दैट मींस आउट ऑफ 20 कौन सी बेस्ट बैंड है विच कैन गिव यू सेपरेशन. तो आप देखिए कि उसमें दो क्लास के बीच में सेपरेशन देगा. अब आप देखिए कि कौन सी 2 क्लास के बीच में सेपरेशन कितना है. सपोज ने दिया 20 सेपरेशन, 20 वैल्यू दिया तो वो बहुत कम है. फिर आप दो बैंड का कॉम्बिनेशन दीजिए, फिर देखिए सेपरेशन हो गया 50. फिर 3 क्लास का कॉम्बिनेशन, 3 मतलब 20 बैंड में से कौन सी 3 बेस्ट कॉम्बिनेशन लेगा जिसके साथ सेपरेशन देगा, तो वहां पे आगे आपको 90 ऐसे बढ़ता जा रहा है. तो हो सकता है कि 10 के बाद वो जो सेपरेशन है वो कांस्टेंट हो जाए.
Okay, sir.
So that means 10 bands are sufficient.
It means that we have to check all the combinations of bands.
Yes. वो उसके लिए उसमें मेथड भी है, उसमें ग्राफिकल मेथड भी है, और उसमें एक जेफरी मैटोसिटा डिस्टेंस है, और एक ट्रांसफॉर्म डाइवर्जेंस है, और एक इक्विलिब्रियन डिस्टेंस है.
Yes, sir. TD मेथड है, GF मेथड.
ट्रांसफॉर्म डाइवर्जेंस का आपका जो वैल्यू है वो 2000 होता है मैक्सिमम. तो 2000 अगर वो 1900 से ऊपर है तो आपका बेस्ट सेपरेशन दे रहा है वो. अगर 17 से 1900 के बीच में सेपरेशन गुड है, 1700 से नीचे सेपरेशन पुअर है.
ओके सर, ओके सर.
ये आप जेनसन में इसकी थ्योरी जेनसन में पढ़ सकते हैं. जेनसन की जो इंट्रोडक्टरी टू डिजिटल इमेज प्रोसेसिंग बुक है उसमें उसने लैंडसेट का एग्जांपल लेके सेपरेबिलिटी को बहुत अच्छे से एक्सप्लेन किया है.
ओके सर. ओके, थैंक यू सर, थैंक यू वेरी
मच. अब अगर टाइम डोमेन, ये तो हुआ स्पेक्ट्रल बैंड्स, लेकिन मैं टेम्पोरल डाटा यूज कर रहा हूं, तो टेम्पोरल डाटा में क्या करना पड़ेगा. टेम्पोरल डाटा में क्या करना पड़ता है कि मेरे पास मैंने सपोज मेरा क्रॉप साइकिल 6 मंथ्स का है और मेरे पास 10 इमेजेस हैं उस टाइम डोमेन की. यहाँ पे मेरी डेट्स चल रही हैं, डेट्स, और यहाँ पे मेरे पास 12 टेम्पोरल इमेजेस हैं. अब मेरे को यहाँ पे स्पेक्ट्रल, तो मैंने 10 बैंड्स थी, हर एक में इस इमेज में 10 बैंड्स हैं, बट मैंने इंडाइसेस लगा के बैंड्स को रिड्यूस कर दिया. पहली चीज तो बैंड्स को क्यों रिड्यूस करना है, क्योंकि क्लासीफायर जो है 3 डायमेंशनल डाटा लेता है. 3 डायमेंशनल डाटा कैसे होता है, आपका होता है कॉलम, आपका होता है रो, और इस साइड में होता है बैंड्स. अब मैं टाइम डोमेन भी ले रहा हूं, एक आपका कॉलम और रो तो फिक्स ही है. अब इधर स्पेक्ट्रल भी चल रहा है और टाइम भी चल रहा है, तो डायमेंशन हो गई 4. तो 4 डायमेंशन का डाटा तो क्लासीफायर में प्रोसेस होगा नहीं. तो या तो मेरे को स्पेक्ट्रल ड्रॉप डिक्रीज करना है, या टेम्पोरल मेरे को डिक्रीज नहीं करना, वो मेरे को मेंटेन करना है, क्योंकि यूनिक सिग्नेचर टाइम डोमेन से ही आता है स्पेसिफिक क्रॉप का. तो मेरे को स्पेक्ट्रल जो ये बैंड्स था, यहाँ पे 10 बैंड्स था हर एक इमेज में, वो मैंने रिड्यूस किया थ्रू इंडाइसिस. कोई भी इंडाइस मैंने लगा दिया, तो हर एक इमेज से मेरे को क्या लेयर आएगी, एक ही लेयर आएगी. यहाँ पे मेरे पास एक ही लेयर है, राइट. नाउ इनको अगर आप लेयर स्टैक करते हैं, तो मेरे पास 12 डेट की इमेज थी, मेरे को 12 लेयर आ गई इंडाइसिस की. इनको मैंने लेयर स्टैक कर लिया, सैंडविच बना लिया. अब मेरे को ये पता करना है कि 12 डेट में से कौन सी ऑप्टिमम डेट्स हैं विच आर गिविंग यूनिक स्टेज ऑफ द क्रॉप. स्टेज का मतलब है फिनोलॉजी, फिनोलॉजी का मतलब है यूनिक स्टेज. उसकी स्टेज क्या है, यूनिक होनी चाहिए उसकी स्टेज, राइट. तो मैं अब इस डेट में इस 12 लेयर्स का सेपरेबिलिटी एनालिसिस करूंगा, और वहां पे नियर बाय क्रॉप देखूंगा. सपोज मैं वीट निकाल रहा हूं, वीट के साथ मस्टर्ड नियर बाय होता है, क्योंकि दोनों एक साथ ही बोई जाती हैं, रबी क्रॉप है. तो मस्टर्ड में गिव यू सेम सिग्नेचर विद वीट. तो मैं दूसरी क्लास भी ले सकता हूं, वहां पे ऑर्चार्ड है, वहां पे और भी कोई ग्रासलैंड्स है, उसको भी ले सकता हूं. ये 4 मेरी क्लास हो गई जो कि क्रॉप की कैटेगरी में आती है लगभग, या वेजिटेशन की कैटेगरी में आती है, बट मस्टर्ड में गिव यू वेरी क्लोज स्पेक्ट्रल सिग्नेचर विद वीट. अब मैंने इन चारों क्रॉप का टेम्परल इंडाइसिस डाटा लेके सेपरेबिलिटी एनालिसिस किया। अब यहाँ पे जो एनालिसिस हो रहा है स्पेक्ट्रल पे नहीं हो रहा है, टेम्परल इंडाइसिस पे हो रहा है। इन चारों क्रॉप का मैंने सिग्नेचर लिया टेम्परल डोमेन में और सेपरेबिलिटी एनालिसिस किया यूजिंग जेफरी मैटोसिटर डिस्टेंस और ट्रांसफॉर्म डाइवर्जेंस, जेएम और ट्रांसफॉर्म डाइवर्जेंस के साथ मैंने किया। तो फिर मैंने वहां पे डिस्टेंस देखा कि वीट का मस्टर्ड के साथ डिस्टेंस क्या आ रहा है और किस डेट के साथ वो मैक्सिमम हो रहा है। तो वो डेट्स का डाटा मैं पिक करूंगा, 12 में से केवल वही डेट लूंगा, सपोज ये डेट है, सपोज ये डेट है, और सपोज ये डेट है, और सपोज ये डेट है। वो बोलता है कि 4 डेट आर एनफ एंड दीज आर द डेट्स। इन डेट्स का मैं इंडाइसिस डाटा लूंगा और फिर उस डाटाबेस में ये आपकी 4 लेयर आ गई यहाँ पे, 1 2 3 और एक 4, ये आपकी इंडाइसिस लेयर है। इसमें से मैं वीट का सिग्नेचर लूंगा और वहां पे फजिल क्लासीफायर लगा के आई विल गेट कि कहां कहां पे मेरा वीट फील्ड है। अब ये मेरे को वीट फील्ड पता लग गया।
ओके, यस सर, यस।
अब मैं सेपरेबिलिटी कर रहा हूं टेम्पोरल इंडाइसिस पे। अगर आप सिंगल डेट लेते हैं तो सेपरेबिलिटी होगा आपका स्पेक्ट्रल इंफॉर्मेशन पे। अगर आप टेम्पोरल ले रहे हैं तो आपको देखना पड़ेगा कि आपने कौन सा पैरामीटर चूज किया। मैंने जनरली इंडाइसिस यूज किया, तो टेम्पोरल इंडाइसिस डाटाबेस पे मैं सेपरेबिलिटी एनालिसिस कर रहा हूं। क्लियर?
Okay, sir. Thank you, sir. Actually, sir, we are trying such kind of work where we are using time series NDVI data sets for discriminating the crops. So in that, it will be useful to perform the separability analysis to see which date is useful for discriminating the crops.
जी जी, मेरा जो एप्लीकेशन मैंने दिया मैक्सिमम क्रॉप पे दिया, तो आई होप इट इज क्वाइट क्लियर।
Yes, sir. Yes, sir. It is clear, sir. Okay. Thank you very much, sir.
Yeah.
Thank you.
Sir, there is a question from students that what do you mean by hard and soft classification?
जी, हार्ड होता है जब दो बच्चे आपस में फाइट कर रहे हैं, फादर एक थप्पड़ मार देता, दैट इज ए हार्ड सेपरेशन बिटवीन 2 किड्स। और जब प्यार से चॉकलेट देके उनको सॉल्यूशन देता, दैट इज सॉफ्ट क्लासिफिकेशन, राइट? सो अगर आप यहाँ पे देखें स्लाइड की मैं बात करूं, आई हैव जस्ट शोन वन स्लाइड लॉन्ग इन द प्रीवियस वन, दिस वन जी, हियर। So here you can see here यहाँ पे हार्ड क्लासिफिकेशन है, मतलब मैंने जो भी मैंने इमेज इनपुट यूज किया, सुपरवाइज या अनसुपरवाइज लगाया, बट मैंने पूरी पिक्सल को एक ही लेबल दिया, वाटर। उसको मैंने ये नहीं बोला कि इसमें 0.5 वाटर है एंड 0.5। जैसे आपका नॉर्मल, आप खुद ही अपने दिमाग से पूछिए कि जब आप कोई टिकट बुक करते हैं और आपका टिकट कंफर्म है, तो आप बोलते हैं यस मैं आई विल गो टू दिल्ली। टिकट आपका बुक हो ही नहीं सकता किसी भी हालत में, पूरी ट्रेन फुल हो गई है, तो आप बोलेंगे आई कैन नॉट गो, टिकट बुक नहीं हो रहा है, क्योंकि रिजर्वेशन तो कंपलसरी है। बट आपका टिकट वेटिंग में है, तो ये जो आपका, जब आपका टिकट कंफर्म है, तो दैट इज हार्ड क्लासिफिकेशन। आप जा रहे हैं यस, नहीं जा रहे हैं नो, यहाँ पे यस और नो है, बीच में कुछ नहीं है, 1 या 0। बट आपका टिकट वेटिंग में है, बट आप बोलते हैं कि 60% आई विल गो एंड 40% आई मे नॉट गो, क्योंकि आपका वेटिंग लिस्ट 10 है। तो 10 में आपका आंसर होगा 60% आई मे गो, 40% आई मे नॉट गो। आपका वेटिंग अगर 1 है तो बोलेंगे 90% आई विल गो, 10% आई विल नॉट गो। हो सकता है फाइनली आप जा ही ना पाए, टिकट कंफर्म ही नहीं हुआ। और आपका अगर वेटिंग 100 है तो आप बोलेंगे 10% आई कैन गो एंड 90% आई कैन नॉट गो, क्योंकि जो वेटिंग टिकट जो इन्फॉर्मेशन है वो इनकम्प्लीट इन्फॉर्मेशन है। तो यहाँ पे हार्ड क्लासिफिकेशन का मतलब है इमेज के कंटेक्स्ट में कि एक पूरी इमेज को आप बोलते हैं कि दिस इज ए बिलोंगिंग टू 1 क्लास। बट यहाँ पे क्या हो रहा है कि ये मिक्स पिक्सल है। मिक्स क्यों पे है? क्योंकि ये बाउंड्री को रिप्रेजेंट कर रहा है। मैंने कहीं यहाँ पे बाउंड्री भी ड्रॉ किया था, नहीं किया था, नो प्रॉब्लम। या सो हियर ये देखिए, ये जो पिक्सल्स आ रही है बाउंड्री को रिप्रेजेंट कर रही है। तो यहाँ पे ये पिक्सल, इतना पोर्शन फॉरेस्ट है और इतना पोर्शन वाटर है, तो ये मिक्स पिक्सल हो गया। और या फिर यहाँ पे ये आपकी पिक्सल है, यहाँ पे ये वाटर है, आपका वाटर बॉडी, ये आपका फॉरेस्ट है। तो ये पिक्सल जो है दोनों चीजों को रिप्रेजेंट कर रहा है। दिस इज ए मिक्स पिक्सल। सो हाउ टू डील इट? सो इसको डील करने के लिए वी हैव टू गो फॉर सॉफ्ट क्लासिफिकेशन। तो आउटपुट में क्या आएगा कि आउटपुट में ये नहीं बोलेगा कि ये पूरी पिक्सल वाटर है। ये पूरी पिक्सल वाटर भी हो सकती है, बट अगर ये मिक्स पिक्सल है तो वो बोलता है कि इसमें पानी 0.7 है, वेजिटेशन 0.1 है, और वेटलैंड 0.1 है, और सॉइल भी 0.1 है। डिग्री ऑफ बिलोंगिंगनेस। सो दैट इज द मीनिंग ऑफ हार्ड एंड सॉफ्ट।
Sir, there is another question coming, whether the same classifiers can be applied in a hyperspectral remote sensing, and which is having a better accuracy, microwave data or hyperspectral data?
नहीं, वो आपको क्लास देखना पड़ेगा कि आप कौन सी क्लास निकाल रहे हैं, और उसके हिसाब से आप बोल सकते हैं कि सारा डाटा इज गुड और हाइपरस्पेक्ट्रल डाटा इज गुड। बट मैंने आपको एक लाइन बोली थी जहां पे स्पेक्ट्रल इंफॉर्मेशन खत्म होती है, मतलब किसी भी एक क्लास को आप निकाल सकते हैं स्पेक्ट्रल इंफॉर्मेशन से, चाहे वो आपकी मल्टी स्पेक्ट्रल इमेज हो या हाइपर स्पेक्ट्रल इमेज हो या सार इमेज हो, और जहां पे वो स्पेक्ट्रल इंफॉर्मेशन जो आप निकालते हैं वो खत्म होती है, उसके बाद आप ऐसी इंफॉर्मेशन, आप यूनिक इंफॉर्मेशन नहीं निकाल सकते, तो उसके बाद आपकी टेम्पोरल कैपेबिलिटी शुरू होती है। तो टेम्पोरल डाटा इज वेरी वेरी स्ट्रांग, जो कि आपको स्पेक्ट्रल से ज्यादा निकाल सकते हैं, इवन फॉर हाइपर स्पेक्ट्रल ऑल्सो। आई एम नॉट, मैंने इतना उसका एक्सपेरिमेंट किया नहीं है, बट आई एम श्योर हाइपर स्पेक्ट्रल से भी ज्यादा आपको टेम्पोरल डाटा से आपको इंफॉर्मेशन आ सकती है। बट मेनली ये क्लास पे डिपेंड करता है, आप कौन सी क्लास निकाल रहे हैं, अकॉर्डिंगली यू हैव टू सिलेक्ट, आपको सार डाटा यूज करना है या फिर हाइपर स्पेक्ट्रल डाटा यूज करना है या फिर मल्टी स्पेक्ट्रल डाटा यूज करना है या फिर टेम्पोरल डाटा यूज करना है। अगर डायनेमिकली, देखिए क्रॉप क्या होती है, ग्रेजुअली चेंज करती है, ग्रेजुअली वो चेंज कर रही है कि ये ग्राफ कैसे पढ़ रहा है, उसका इंडाइसिस बढ़ रहा है, शुरू में ये फैलो था, फिर उसका एनडीवाई बढ़ रहा है, फिर पीक पे जाता है, फिर यहाँ पे कांस्टेंट होता है, फिर थोड़ा ड्रॉप करता है, फिर बढ़ता है, फिर घटता है, ऐसे करके जाता है। क्योंकि यहाँ पे पीक पे गया, फुल ग्रोथ हुआ, फिर फ्लावरिंग हुआ तो ड्रॉप हुआ, फिर ये मिल्किंग के बाद हार्डनिंग हुआ, फिर सीड्स का, फिर ड्रॉप हुआ, हार्वेस्टिंग हो गया। तो ग्रेजुअली चेंज कर रहा है। अगर कोई पार्किंग एरिया है, वहां पे कार पार्क हो रखी है, तो यू कैन यूज सिंगल डेट, क्योंकि वो चेंज नहीं हो रहा है, आप सिंगल डेट भी यूज कर सकते हैं, मल्टी स्पेक्ट्रल या पैनक्रोमैटिक। अगर आपको मिनरल्स या स्पेसिफिक वेजिटेशन का मैपिंग करना है, यू कैन ट्राई फॉर हाइपर स्पेक्ट्रल, बट उससे भी ज्यादा आपको टेम्पोरल से बहुत ज्यादा इंफॉर्मेशन आएगा, क्योंकि वो पूरा उसका साइकिल को कवर करता है। यहाँ पे पूरा क्रॉप साइकिल इंक्लूड कर रहा है, और वेजिटेशन में एनुअली और 2 इयर्स का उसका साइकिल आप इंक्लूड कर सकते हैं यूजिंग टेम्पोरल डाटा। 2 साल में या विद इन 1 ईयर वो पेड़ कैसे चेंज करता है, वो लीफ शेड करता है या फ्लावरिंग होती है, उसमें क्या होता है, या पार्शली लीफ शेड करता है, उस इंफॉर्मेशन को आप टेम्पोरल से इनकॉर्पोरेट करा सकते हैं, एंड देन यू कैन प्रोसेस।
Sir, there is another question coming up. Can microwave data be used for identification of different kind of surfaces in terms of building materials when we go for classification of building footprints?
Yeah, you can do with SAR also. मैंने SAR को केवल इंटीग्रेट किया है ऑप्टिकल में, मैंने एक 2 एप्लीकेशन दिखाए थे यहाँ पे। But if you want to use individual SAR also, you can try and you can see can you get the results. Basically, आपका अगर रिसर्च ओरिएंटेड माइंड है, तो यू बेसिकली, रिसर्च मीन्स डूइंग एक्सपेरिमेंट, एक्सपेरिमेंट मीन्स doing the same thing with different angles, so you can try to do that. And here as per my expertise I've done SAR को मैंने उसको इंटीग्रेट करने की कोशिश की, एंड 13 जुलाई के आसपास मेरे पास डाटा नहीं मिला, तो मैंने SAR को यूज किया और उसका बैक स्कैटर कोएफिशिएंट यूज किया। अभी मैं उसका एक्सपेरिमेंट कर रहा हूँ, कैन वी यूज इंडाइसिस फ्रॉम SAR इमेज एंड ट्राई टू इनकॉर्पोरेट विद लैंडसेट एंड सेंटिनल-2 डाटा। अब बहुत लोग बोल सकते हैं कि ये तो 10 मीटर पे है, ये 30 मीटर पे है, और ये आपका SAR का डाटा एकदम अलग है, कैसे आप यूज कर रहे हैं? तो मेरा एक सिंपल सा क्वेश्चन है कि पंजाबी गर्ल तमिल बॉय से के साथ कैसे सर्वाइव कर जाती है मैरिज में, आफ्टर मैरिज? सिंपल है, we have to see, we have to respect each data sets and try to use the capability of the data. वो डाटा क्या इंफॉर्मेशन दे रहा है, उस इंफॉर्मेशन को इंटीग्रेट करना है। और यहाँ पे 10 मीटर पे मेरे को इंडाइसिस मिल रहा है, और ये 30 मीटर में मिल रहा है। 30 मीटर को मैंने 10 मीटर पे यूज किया, क्योंकि वो 30 मीटर को डायरेक्टली थोड़ा कॉम्प्लिकेट हो जाता है, तो मैंने इसको रिसैंपल कर दिया 10 मीटर पे, और यहाँ से मैंने बैक स्कैटर कोएफिशिएंट यूज किया, और बैक स्कैटर को मैंने 8 बिट में स्केल कर दिया। सारा डाटा मैंने 8 बिट पे स्केल कर दिया, एंड वी कैन यूज इट। तो पहली चीज ये है कि आप अपने चारों तरफ बाउंड्री बिल्कुल भी ना बनाएं। बाउंड्री बनाते हैं तो बाउंड्री आपकी इन्फिनिटी पे होनी चाहिए। आप पहले बोलने लगते हैं ये नहीं होगा, वो नहीं होगा, ये कैसे होगा, तो आपने एक निगेटिव बाउंड्री बना ली अपने चारों तरफ। उस निगेटिव बाउंड्री, दैट निगेटिव बाउंड्री डज नॉट अलाउ यू टू डू द सम ऑफ द थिंग्स। तो जो एक छोटा 1 साल का बच्चा होता है, वो क्या करता है, वो उसको कुछ भी दीजिए, आप स्लीपर दीजिए, शूज दीजिए, चॉकलेट दीजिए, वो सब कुछ ले लेता है, वो कुछ किसी भी चीज को मना नहीं करता है, क्योंकि उसके पास कोई भी निगेटिव बाउंड्री नहीं है। ही एक्सेप्ट्स एवरीथिंग। सो फर्स्ट थिंग इज ट्राई टू एक्सेप्ट एनीथिंग यू गेट, एंड देन यू चेक how much it is useful and use it. I told you one statement, everything is useful in this world. So आप कुछ भी जो है वो यूजफुल है। आप बोलेंगे no it is not possible, I will say yes again. Like आप अंडा खाते हैं तो आप अंदर का चीज खाते हैं, उसका कवर नहीं खाते हैं, but there are other people, other creatures who eats, dog is welcoming to eat the cover. और कंपनीज क्या करती हैं, वो कवर को नहीं फेंकती हैं, कवर से कैल्शियम, मैग्नीशियम, पोटेशियम भी निकालती हैं। तो अगर आप जो भी आप कंपनीज में देखेंगे, दे आर प्रोसेसिंग ऑल दिस आइटम्स, सो नथिंग इज वेस्ट इन दिस वर्ल्ड, प्लीज रिमेंबर। सो विद दैट इट टेल्स यू एवरीथिंग इज यूजफुल। अब आपको देखना कैसे उसको यूज करना है।
So finally, sir, all the questions have been answered, and still, if some questions is left out, the students can contact you directly. And
Yeah.
sir, on behalf of Center for Climate Change and Water Research, I take this opportunity to thank you for providing us insights about different kinds of classifier techniques, the latest classification techniques that we are using, deep learning, and the students were very interactive, and they have understood a lot of basics and the advanced techniques. And we hope that in near future also you will be blessing us, and we will be in continuous contact with you for our further research. Thanks a lot, sir.
Okay. Thank you. Thank you all for listening.
Thanks.
Thank you, sir.
Thank you,
Priyanka?
sir. Thank you for such detailed information and presentation. I hope all of you are enjoying this esoteric program. Now, moving forward with today's event, I would like to take a brief moment in introducing our next speaker, Dr. Lakshmikant Sharma. He is Associate Professor of Department of Environmental Science at Central University, Rajasthan. Dr. Lakshmikant Sharma completed his MSc and PhD degree in botany with specialization in ecological environment from University of Rajasthan, and he has received PG diploma as well as MTech from in remote sensing and GIS from Indian Institute of Remote Sensing, Dehradun. He has authored many peer-reviewed journals, international and national level. He has many book chapters, books, and has been a member of several editorial book international journals. Now, he is life member of a society like Science of Climate Change and Sustainable Development, International Society of Environmental Botanist, Indian Science Congress Association, and many more. He has extensively worked with multi-sensor advanced remote sensing data with research support from MOEFCC, SAC ISRO, NRSC ISRO, on forest fire modeling, natural resource management, assessment of forest biomass with multispectral, microwave and LIDAR, and many more. On this note, I would like to invite Dr. Lakshmikant Sharma for taking forward today's event. Sir, you're most welcome.
Thank you, Priyanka. And
thank you, sir.
Thank you so much, Dr. Shruti Kanga and Dr. Suraj Kumar, for inviting me for this useful event. And I think, I hope you are learning well in the field of this remote sensing and GIS. Now I'm just sharing my slides. So I think it is visualized.
Yes, sir.
Okay. So first of all, you may already achieved a lot of things in this duration of this 10 days training period, 21 days training period. But little bit from my side, I would just like to add some points regarding the image classifications. So I'll just start that some of the things. You know very well that how we are just starting our remote sensing journey from past to the present scenario. And now we can say that the journey is too much advanced, not only in the field of this monitoring of the environmental aspect, but also for the different type of the pattern analysis and the classifications related to different domains like earth resources and some of the very prominent features in the classifications we have already achieved. With the time period, we are just doing much more in that way. So you just see that I'm not going again to detail in the particular theory portion.
Full screen mode. will be better.
Full screen? Okay. Now it's okay? It's okay now?
Yes, sir. Yes.
Okay, okay. So now, because on the basis of this, light energy intensity in terms of EMR radiations, the three things you can say generally behave the EMR. One is the reflected mode, one is the emission mode, and one is the transmitted mode. So energy in terms of this one, if we are taking, then different kind of the remote sensing you can say, the types of the remote sensing you can generate, like microwave remote sensing, thermal remote sensing, and different optical remote sensing patterns also. And this is a simple phenomena. I'm not going into the detail, but this is a brief overview that how the remote sensing is working, and different themes are there. But main thing is that how the different objects on the Earth's surface are creating behavior on the particular EMR radiations. That is more important in all the remote sensing. And without going into the field, no any remote sensing will work. So the field work is very, very essential part in the remote sensing, because you cannot find a much more fine accuracy without going to the field or field data collections. Simply, if we are going into the creating the themes in different forms, like AI right now using in that way, deep learning is using, and so many other ANN and fuzzy logic, artificial neural network, so many things we are including in the remote sensing every day. Different themes are coming, but at least I'm saying that my experience is that without ground to thing or without field survey, without a prior knowledge of the particular area, I think the resolution or the fine accuracy we can't achieve. So this is most in the case of the remote sensing. Now you may aware all these things in your previous slides or previous lectures, that different type of the orbits are there, like polar and geostationary, energy sources, passive and active, and visible, infrared, microwave remote sensing, measurement techniques, resolutions, different resolutions maybe you are aware, and different applications you are just going on, but little bit of this one is there, and definitely not only a single field is left behind this one in the application part, in which the remote sensing or the geospatial technology is not working. So I think it's a large area by which we can easily go into this one. So in simple way, if I describe in remote sensing, GIS and GPS, then we can say remote sensing will provide a large and synoptic view, GIS will provide a decision-making system, and the GPS will provide the positional accuracy. So simply all these three things in a single window platforms, if we are using, then it will be a better solution for different type of applications to solve the real world problems. And this is the things that how the different sensors are working. Maybe the push broom and the whisk broom sensor is working, and the techniques is generally evolving, and different type of techniques are right now available, maybe in the CCD network format and other formats also available. But now the solar panels is also very, very important part playing in terms of the sensing systems, and different applications and advances also already came into the picture for taking the scenario of this sensing system. Now the question is that the land information extraction from satellite images, how we can actually gather the information, and what is the need for this classification actually. So the basic theme is any type of remote sensing images that if we are not taking any part for this is the ground relative form, then how much accuracy you have to follow for this one. So that is the most important thing, that the accuracy part. So you see the map of the categorical variables and the map of thematic classes is undergone. Then I think you see the land cover maps burn area maps, flooded maps, agriculture maps, forest maps, all these maps you have to generate it. That is in the thematic remote sensing image classifications. But similarly, if the data is providing in the format of the sum of the continuous variables like the leaf area index, biomass, tree volumes, temperature, precipitation, rainfall, all these are the quantitative remote sensing modeling, and that will comes usable in the form of modeling purpose. So different parameters are there in the landform information extraction in the satellite images that is more important in terms of this particular type of the identifications. How we can identify the particular object on the Earth surface, that is more important. So whole and soul, the basic theory behind this one in the entire remote sensing platform is that how we can identify how much identified the object and in which way we are identifying the object. That is more important in terms of this one. So you see the traditional approach for land cover mapping is that we are just taking the different imageries and different pixel classifications at the pixel level we are going, and ultimately categorical classifications we can do. That is most traditional approach. But in the process of this image classification, spectral classes assigning the informational class names, particularly the spectral classes, like you see the picture that the different group of pixels that are uniform with the respect of their pixel values in several spectral bands. And you see the informational classes, when we go into the land cover mapping, then it will be categorized in different type of the terrain like water, forest, urban, agriculture, and so on and so on. So this is the things that, but this one is how much accurate and how much accuracy is follows. And whether this one is correct or not, that is also a prominent features in that way. So the things behind this one that simply we are using the data which is freely available on the internet or any other sources, and ultimately you can see that these type of data set may be feasible for this type of applications or not. That is also a very, very remarkable question in this regard. So the things is that, so in that particular things identification, generally in remote sensing, classification methods are described in three ways. One is unsupervised classification, supervised classification, and the object-based image classification. In recent advances in satellite image classification, that the different algorithm classification algorithms developed, like artificial neural network, decision trees, and that can be categorized as a different pixel level classification, sub-pixel level classification. Means if the pixel has different classes also, because some may be pixel in the merged format also. So the classes may be overlapped in the particular sections. So if the overall approach applied to the entire imageries, then it will be created different, accuracy may be decreasing in terms of this identifying all these points in a single platform. So the question is that how much accuracy we have to attain and in what way we can do, that is more important. And in terms of this one artificial neural network and decision trees also very well applying. Development of new system level approaches that augment the underlying classifier algorithms because some type of the phenomena like fuzzy and you see the crisp logic methods. Fuzzy is providing the soft classifications in terms of this their layers, the particular type of the functions which classes will be assigned. That is also more important in classification algorithms. And the multiple types of the ancillary information like numerical and categorical, this classification process can also be used for the overall classification systems. So you see image classification at pixel level, the question comes that does it satisfy the user's need? The first thing is, which is very common questions everybody's mind. Because what we are actually taking from the pictures, actually we want to know our resources, how much amount of the resources, in what capacity they are extending, in what capacity they are decreasing, what is the qualitative segment is there, what is the quantitative segment is there, each and every pixel, how much value they are gaining, each and every aspect we have to categorize. So this type of the classification is very much needed, which is showing the real world situations, real world problem solving in the particular aspect. So the recent research is telling that the new classification algorithms, a new spatial unit of analysis, spatial analysis for map generalizations, that will again combinedly created to the redefine the approach for thematic information extractions. So I'm not saying that the overall experience is not well defined, but different other parameters like the recent strategies in terms of the likewise the deep learning, which is previously you have taken the classes in this regard, that is also showing a common phenomena for the image classification. But the main important things what happen in that particular classification system, if you are categorized at different criteria, then one important thing is very, very promising factor, which is minimum mapping unit, MMU. And in raster maps, the MMU usually is the pixel. So pixel level classification and subpixel level classification, if we represent in the vector maps, and ultimately the different portions, if we represent it in the maps, then definitely our LULC maps will be more refined. So pixel level information is much more needed, and subpixel level integrity and classifies accuracy, that is also be prominent in that way. Spatial unit of analysis, you see the images, that the image pixels and object, and one of the right side, the per pixel or subpixel classification and object oriented image classification. You see the minimum mappable unit is the final map creation, and ultimately it will create the things that some of the pixels values may be merged with the other object also, and in that case the classification will be not much more accurate in that way. So that's why accuracy is a prominent feature in any type of the classification, whether this one is a supervised, unsupervised, or whatever. Accuracy is much more needed. Now, one important feature is also very, very important and very recently approached, that is image segmentation, object image segmentation. Some of the algorithms and some of the softwares using the automated image segmentation approach, they are also using. But definitely, I'm already telling the accuracy will matter, and ultimately it will be described in terms of some number of the problem solving, but in a large number of the image identification, that may be due to some accuracy problem is there. So right and wrong situation, that is not a capable things in the image classification. That means that either this one is 1 or 0, or the computer format is telling that this one is buildings or not, maybe this one building or not. But in the picture format, when you classify the image, then some of the area may be also covered with the forest region, some may be area with the other object classifications also. So in terms of this image segmentation approach, somehow we can also overview of all these situations, and ultimately some of the information we may get recently. Now you see different possibilities to categorize the classifiers, and the type of learning like supervised and unsupervised, and number of outputs for each spatial unit. We can say that this one is the hard classification as well as the soft classifications, and the type of learning supervised and unsupervised. And you can also categorize the assumption on data distribution, parametric and non-parametric. Some of the classifiers are also using. Now on the type of learning, you can see supervised classification and unsupervised classification. Supervised classification has definitely, you have some of the training site or training divisions is there, which is well known a priori situation is there, and ultimately you can create different type of the map or the classification you can generate. But in unsupervised classification, you have random number of the DN values, and ultimately you have to select one or two of the classes, and ultimately you can give the different segmentation approach for dividing different type of objects. But no need to you can say the training site is required in that unsupervised classification. But definitely some type of if the data is very, very high and the process required much more reducing the algorithm approach, and the much more storage capacity is delineating, then ultimately the unsupervised classification is needed at the time. On the basis of the assumption on the data distribution, parametric classifiers and non-parametric classifiers are also using, like parametric like maximum likelihood classifiers, and non-parametric like decision trees, artificial ANN, support vector machine, nearest neighbors, and all these things are there. So traditionally, most classifiers have been grounded to a significant degree in statistical decision theory. The classifiers rely on assumption on data distributions, and the performance of a parametric classifier depends largely on how well the data match the predefined models and on the accuracy of the estimation of the model parameters. So this is the way by which we can categorize the different classes also. Allocation of a class of each spatial unit of analysis, SUA, and you see the image feature space, likewise band 1 and band 2, if you see the situation, then the image feature space will be generated, and ultimately the non-classified pixels and the classified pixels will be augmented at that moment, and you can also divide in some ways by the classification. So decision boundaries to separate classes, that is also in vector clustering, a set of measurement, that is also a very good example of this classification algorithms. Decision rule is the algorithm that defines the position of a SUA, a spatial unit of analysis, with respect to the decision boundaries, and that allocate a specific level to the SUA. So decision trees is also a very, very unique applications in terms of the classification approach. Number of outputs for each spatial unit, if you are categorized, then the hard and crisp classification, you can say the soft classification like fuzzy classification and hard classification that can be categorized. Like in hard, each pixel is forced or constrained to show membership to a single class, whereas in soft classification, each pixel may display multiple and partial class membership also, like vegetation, waters, bare soils, and so on. So in that case, soft classification has been proposed in the literature as an alternative to hard classification because of its ability to deal with mixed pixels. So in nature, generally, the classes may be in the mixed classes or mixed pixels. So definitely, the soft classification is much more advantageous in terms of the other hard classification systems, but definitely they have also the hard classification also have some type of the significance values, and the biasness may be also very less in terms of the hard classification. Now, supervised classification in remote sensing, you see the digital image is showing that different type of the objects, like when you go for the forest classification particularly, then suppose if you want to go with the forest classification, you should have a prior knowledge of the classification system of the forest, which is applied in the Indian subcontinent or something like that. In India, generally we are following the champion and set classification systems. So at first you should know about that what type of the classifications we are adopting, and then on the basis of the a priori knowledge of the particular area that is also required, and then you can go for the training sites, and particularly you may recognize the conifers, water bodies, and deciduous forests, so known area deciduous forest, and ultimately you mix up all these things, and ultimately you can get the different classes in the supervised classification. And if you see the spectral variations, you see different classes, different variations on the spectral regions, and it is clearly shown in the different bands also. You can see this is the way by which we can segregate the different classes. The spectral signatures of each pixel gets matched with the turning signatures, and the image is classified accordingly. And the spectral signature of each pixel get matched. You see the spectral image is also some type of information is there, and spectral signatures to next level to be classified. And the mean spectral signatures you can easily get with the different forest types also within a segment of the forest patch. That is most important things is there. And the classic supervised classifiers, the minimum distance, you see different band combinations, and in which the minimum distance, which is very nearer to the accurate classifiers, that is also a segment is created in that way. That is also comes under the supervised classifiers. Minimum distance, parallelepiped, and the maximum likelihood classifications. So in terms of this one, these are his pros and cons are also there. Different algorithms and different biasness factors is also there. But definitely, in terms of the accuracy moment, definitely the supervised classification is much more authenticate rather than the other things. But you have to need the training side. That is most important things there. And non-parametric classifiers, generally the like artificial neural network is there. You see different input and output layers, some hidden layers is also there, and then you have to classify it in different classes on the basis of this ANN format. And you see different set of parameters is also required to create the different clusters on different classes. Again, you see ANN is also comes in terms of this type of learning like supervised and unsupervised, and number of output labels that is also comes in the form of the hard and soft. So the multi-layer preparations and back propagation methods, self-organized feature maps, Hope film network, ART approach, and different so many. This is not the limited one. Different other approaches are also going on into the picture, and different peoples are working on this one. Advantage of ANN is that it's a non-parametric classifiers. It does not require any assumptions about the statistical distribution of data. Whereas the disadvantage is that ANN are semantically poor. It is difficult to gain any understanding about how the results was achieved. And again, one of the negative factors of the ANN is that the training of an ANN can be computationally demanding and slow. And you know, the biasness chances in the computer phase domain is also a very, very massive factors. So in that way, some of the advantage and disadvantage is also liable with this one. So in that case, I'm not considering about all these training stages in the terms of ANN, but this is the way, this is a simple way I'm just describing in a parametric manner that how the things is going on in the non-parametric and parametric classification. This is the decision tree classification in which different input pixel reflectance values are there. And you see one of the parametric boundaries is you can define at the first level, which maybe arise in the true and false. And if the condition is there, the condition you have to apply it, different conditions you have to apply it. And again, in the questionable format that whether this is true or false, you can easily define the different structures and different parameters. So decision trees is also a knowledge-based classifiers, and it's a hierarchy rule-based approaches particularly because some type of the hierarchy is also involved in this type of the parametric, non-parametric classifiers. Disadvantage of this decision trees is that the use of hyperplane decision boundaries parallel to the feature axis may restrict their use in which class are clearly distinguishable. That is the only one major disadvantage. Otherwise, a very, very good advantage of this one decision trees, like good computational efficiency and can reveal non-linear and hierarchical relationship between the input variables and use these to predict class membership also. So this is the things by which you can easily create the classifiers in the mixed pixel problems. And landscape fragmentations, sensor spatial resolution, that is also a very, very important factors. And you see how much clearly we can visualize the classes. And the mixed pixel problem, that is also a different kind of, like Iconos and Mary's product also, you see different kind of the mixed problems. And every time, the one most thing is that if we are getting any type of the satellite data set, the mixed pixel problem always exists there. So that is the most challenging part in terms of the accuracy, that how we can go with the different algorithms to eliminate all these mixed pixel problems. So that is our main motto. Soft classifiers, mostly maximum likelihood, fuzzy C-mean theory, possibilistic C-means, fuzzy rule-based classification, ANN. All these are the common classifiers that is going to be used right now. And you see the decision making, how you can decide, like maximum likelihood, one decision tree and artificial neural network. And of course, the decision tree is much better than the other things is also there, because a prehistoric knowledge and the particular hierarchical based the things is there in decision tree, that will also combine with the neural networks and ultimately gives the better result in terms of accuracy. So, this is the supervised, unsupervised classification, that how we can think about this one, and what type of the parameters we have taken in the geographical domain. Ultimately, the pixel object is the most prominent features to identify the classes particularly. Now we are coming to the unsupervised classifications. So generally in two common methods in unsupervised classifications, they are generally using the chain methods and isodata clustering. That is also a important things. So it requires only a minimum amount of initial inputs from the analyst. Numerical operations are performed that search for natural groupings of the spectral properties of pixels. The user allow computer to select the class means and covariance matrix to be used in the classification. Once the data are classified, the analysts attempt a post-priori to assign these natural and species spectral classification. Whereas when you compare with the supervised classification, a priori knowledge is also required. That is a very, very basic difference between the two of these systems. And some clusters may be meaningless because they represent mixed classes. So again, the mixed classes problem is always there. And I think whenever we are using in terms of this artificial neural network or deep learning or whatever we are using, definitely the accuracy level may be differ, but definitely the mixed pixel classifiers, mixed pixel classes will be defined with the accuracy also. Accuracy will be, disturbance, providing disturbance in some way. So this is the way by which we can definitely demanding in terms of the clustering approach. Chain method operates in two pass modes. It passes through the registered multispectral dataset 2 times. In the first pass, the program reads through the dataset and subsequently build clusters. A mean vector is associated with each cluster. In the second pass, a minimum distance to mean classification algorithm is applied to whole dataset on a pixel by pixel basis, whereas each pixel is assigned to one of the mean vectors created in pass 1. The first part automatically create the cluster signatures to be used by the supervised classifiers. Cluster building, you see, during the first pass, the analyst is required to supply 4 types of information: R, C, and R, the radius distance, C is the spectral space distance, and the N is the number of pixels to be evaluated between each major merging of the clusters. C maximum number of clusters to be identified. And in pass 2, assignment of pixels to be one of the C max clusters using minimum distance classification logic. And again, in different other aspect, the isodata clustering, the iterative self-organizing data analysis technique, isodata, represent a comprehensive set of heuristic rule of thumb-like procedures that have been incorporated into an iterative classification algorithm. Iteration means the different same type of the classification in the iteration mode we have to use for this type of the isodata clustering. Isodata is iterative because it makes a large number of passes through the remote sensing data set until specified results are obtained instead of just 2 passes. So isodata does not allocate its initial mean vectors based on the analysis of pixel rather than initial arbitrary assignment of all C-max clusters take place along an n-dimensional vectors that runs between very specific point in feature space. So isodata clustering normally requires the analyst to specify the C maximum, T maximum, M maximum. M is the maximum number of times isodata. T is the maximum number of percentage of pixels whose class values are allowed to be unchanged between iterations. C maximum number of clusters to be identified. So maximum standard deviation for a cluster that can be also standardized in the isodata clustering. Minimum distance between cluster means that is also a features which can be added in the isodata clustering. So overall, supervised versus unsupervised, if you claiming, then select training field is required, edit or evaluate signatures, classify the image and evaluate classifications. Versus if you find out the unsupervised classification, run the clustering algorithms, no need for training field or data. Identify the classes, no need to evaluate signatures or edit the signatures. Classify the image in terms of the evaluate signatures, then again, after this portion, you have to evaluate the signature from the when you're running the cluster algorithms. And ultimately, classified image which can be automatically generated in the evaluated classifications. So some type of the very basic difference in between them, supervised and unsupervised, but definitely supervised is better than the unsupervised. But some of the limitations in supervised which can be overcome in the unsupervised classification. So this is some of the basic differences between the supervised and unsupervised classification. And this is a predefined classes, and this is the unsupervised unknown classes is there. No classification errors is required, and in supervised, serious classification errors detectable. So I think this is the way. Basic thing is that the previous knowledge is required in supervised classification, whereas in unsupervised, you may avoid the pre-knowledge requirement and some type of the accuracy you have to achieve, but not in a significant way. So that's why the derived clusters may be unidentified in some way, and a priori clustering and the post priori clustering, that is also a common difference between the supervised and unsupervised classification. So algorithms, that is some of the differences between the unsupervised and supervised classification, and some of the issues with unsupervised learning is that it's harder as compared to the supervised learning task. And the question again in terms of this, how do we know if results are meaningful since no answer labels are available? Let us expert look at the result. External evaluation is required. Define an objective functions on clustering like internal evaluation is also required. So the question is that why unsupervised learning is needed despite of these issues? What is the need? So the answer is that annotating large data set is very costly, and hence we can label only a few examples manually, like speech recognitions. There may be cases where we don't know how many or what classes is the data divided into. So some example data mining. In that case, unsupervised learning, unsupervised classifications overcome the situation. And the third, we may want to use clustering to gain some insight into the structure of the data before designing a classifiers. So some of the advantage and some of the disadvantage, definitely, but in some cases that is also usable. And moreover, the accuracy wise maybe differ, but some of the application part wise, if you see, then it is also required. Simply in the hyperspectral image classification data, different type of the latest advanced techniques is also available, and you see bulk amount of data, number of bands is there in hyperspectral images, and you see a very contiguous bands is there in hyperspectral data cases. Unsupervised classification is showing a much more good example to utilize the unsupervised classification. So these are from my side. Thank you. And if you have any question, then you can ask me.
Any question, please? So, sir, I'll be taking few questions from the chat box, what the students have given me in my personal WhatsApp chat. Ki, sir, which data provides a better classification accuracy, hyperspectral data or microwave data?
For accuracy point of view, I can say you cannot determine that which type of data will provide the high accuracy. That is also a question of applications. In what application you are using the data. Suppose accuracy, meaning the accuracy is something different. That is also a application based parameter. Like if you want to make some type of the dam preparation or some type of the like forest regeneration strategies or some type of the other application part, and in non-accessible area, then definitely the microwave data will be usable. But in terms of the qualitative aspect, definitely the hyperspectral or the quantitative aspect, hyperspectral data classification will be much better in accuracy wise. So maybe it will be depends on the particular application, particular type of application, that in what way we are using the data and what type of the application is required.
Okay, sir, and which data is good for forest biomass studies?
Data forest biomass studies, because biomass, is a dry weight of the living things, and the biomass study is directly resembled with the climate change situations right now, and it's a very global phenomenon. So as we are doing this type of approach in different algorithms and different type of the data set we are gathering, and like the penetration part of this one, forest has a different branch stories, like topmost forest area to the middle portion of the forest and the lower portion of the forest. And ultimately the optical data has very much biasness, because the soil part and the soil moisture part will also affect the reflection part of this imagery. So in terms of the optical data set, that is not much more better classifier in terms of this forest biomass study, but definitely the microwave data is much more better, because it will reduce the bidirectional reflectance also. It will different stories like the upper story of the forest, the middle story of the forest, and the lower story of the forest, and they can be also minimize the effect of the bidirectional reflectance effect, which may be arise due to the soils and the water bodies interactions. So that may be reduced with the microwave imageries. And so, and hyperspectral, again, it will create the species level demarcation, definitely. But now these days what happening, hyperspectral is not provide a good result in terms of the biomass, particularly because we cannot achieve so much accuracy in terms of the heterogeneous forest batches. So in that cases, microwave data for the forest biomass study is good, and for particular different bands of the microwave like Ka band, Q band, X band, C band, S, L, P band penetration power is more, but the wavelength is very less. So in terms of this one, the L band data like Elos pulsar data is very, very accurate in terms of the forest accuracy, forest classification accuracy.
Sir, there is another question ki how, because you're from environmental science, so some of the questions are coming from environmental aspect ki how should we proceed for carbon footprint and REDD++ studies?
Yes, REDD++ studies, you just read our paper, which is firstly published in the International Journal of Environmental Monitoring and Assessment, and the paper was based on entire Himachal Pradesh area, and it's a first technical paper on the REDD and REDD+. So REDD basically a forest monitoring purpose, monitoring aspect is there. So in terms of the classifiers, when you are using the decision tree is very, very usable format for the REDD and REDD+ activities. And in terms of this, because REDD is only you can say a monitoring aspect, and now these days what happening, a specific satellite is already launched by the European Commission, which will be recorded the forest biomass data itself. So directly you can get the biomass data. No need to evaluate the biomass. You will get, as like as the MODIS, if you are using the biomass, then you have to generate the different NDVI images, evapotranspiration data, and the other LEI data is very, very easily available and easily downloadable. But right now the situation is that the advancement is like that you can easily get after some time the biomass data from the satellite images directly.
Sir, again, two personal questions from my end. So today there has been a report of
sorry, your echo is coming. Voice echoes. Sir, one by one. Yeah.
Sir, today there is your report, published report in the newspaper that you have said something very strategic and very dominating, that the findings of COP14 regarding the Aravallis, and they have suggested a construction of some walls, and your finding has a contradictory result. Sir, can you please brief us, and so that our participants can also know about your research?
Yes, yes. Recently, today, one of my research, which was already published in the International Journal of Earth Science Informatics, which is based on the Aravalli region. And actually, our result is telling that how much Aravalli is a world oldest hill ranges, and it is the ecotonal region between the Desertic region and the Gangetic plain. So Aravalli is a boundary wall which is naturally providing, you can say providing a wall between the two of the ecosystems, and it is providing us for the different cloudy storms and some of the other catastrophic effects due to arising due to the global climate change situation. So our study is telling from 1975 to 2019 satellite data we have downloaded and analysis that how the scene was created in terms of the Aravalli, that how much part is converted into the different classes. What classes we have used, like forest is also converting into the grasslands also, and grassland also converted into the vegetation lands also. So, and some of the area is converted into the mining land also, and illegal mining is showing a very great effect on the particular forest degradations in the particular area in Aravalli. So and again we have also forecasted the things from 2019 to 2059 using the CART classification regression tree analysis, one of the classifiers we are using. And ultimately we have future predictions we have also find out. And that we have also find out that how much the forest area will convert it into the degraded lands in near future, in up to 2059. So this is the story was that, and ultimately in terms of the COP14, as per the United Nations Combat for Desertification Conference, COP parties meeting in 14, which was held in Noida in Delhi in 2019. And it was telling in that meeting that we should try to develop a green wall around to save the particular desert storms and desertification. So, and government is planning to develop a proposal that a green wall concept was coming into the United Nations level in Africa, that from Africa to Senegal, from one part, east part to the west part, one green wall should be constructed. So same idea will be generated by the government in India in the Porbandar to the Panipat areas is a 14,000 crore rupees project they have proposed. My question is that we have a very specific natural green wall is available in the form of Aravalli. So why not we should reconstruct, or why not we should regenerate in the term of the restoration decades of the United Nations already declared. So in the decade of this United Nations restoration decade, we have to conserve, we have to save our Aravalli, which is a natural green wall, and ultimately we have to consume our money in terms of the more exploitation of the Aravalli region, in terms of the illegal mining and encroachment and biodiversity loss. We have to overcome this situation by using the restoration of the Aravalli only. So that is our conclusion part of this particular study, which is published in the Lokmat Times, today's Lokmat Times also.
And also, sir, because we are stationed in Rajasthan, there is another popular study that is of very common nowadays in Times of India and Hindustan Times, where you stated some of the finding related to Sambar wetland. Sir, can we know what was the major findings and the outcomes of that study?
Yeah, we are actually our university in surrounding in the particular domain of this wetland. And wetland is the Sambar Salt Lake. This is the Sambar is nearer to the Jaipur, Ajmer, and you can say the Nagaur district in between them. Sambar is a salt lake, and it is a Ramsar site. And it is a salt lake. Due to this salt lake, actually, this is the one of the best important place where edible salt is available. No any other places you will get the edible salt. Only the Sambar Salt Lake providing this one. And unfortunately, what happened due to the time being, the encroachment is there in the Sambar Lake. And due to this encroachment, people are doing illegal mining of the salt. Where the Sambar Salt Limited is there, but the illegal salt producing is also there. And the quantity of the illegal salt mining is 3 times faster than the government productions. So it is directly, targeted to the government earning monies. And you must surprise that from 1965 to current situations, it is the lake is shrinking due to this encroachment. And this is only the production of the salt only, but it's a wetland. We should not forget about it's a wetland, and wetland is a carbon purification systems. A natural carbon purification system. They store the so much methane and carbon dioxide in their oven. So for the climate change study, we have to conserve our natural wetlands. So in this particular study, we have targeted that how much area of the particular lake is sinked and how much we can restore. And for the particular classification algorithms we are using, and different modeling approaches if you are taking, then ultimately this type of the the features we have come out that ultimately we have to much more attention toward to this Ramsar site, and government is trying to develop a recreational site for this one. And the migratory birds which are coming to this particular Sambar Salt Lake places, which is actually a great recreational site for the bird watchers, but bird loving points. But now this is what happening. So many birds are dying due to the different type of the mismanagement is there, and algal foods, rhodophyceae is also a major important source for the products for the habitat constructions of the particular birds. But right now this is day by day deteriorating, and so many other sewage plants and so many other activities are running side by parallelly in this particular lake. So we have to restore, we have to conserve this our natural resources so that we can plan much more in the particular in upcoming scenarios. We are not saying that we should try to stop all these things like the developmental activities should be stopped. But what happens if the wetland is gone, then definitely our natural carbon sequestration powerhouses will be gone, and definitely we have to conserve. So that is our research is telling, and this is the eye-opening research we are just doing in terms of this surrounding areas, and that is the great study is a real sense we can attribute, or we can distribute some of our knowledge to the grassroots persons also. They can understand easily that how the things is going on in our nearby areas.
Sir, Bhavna wants to ask something question directly to you.
Yeah.
Yeah, Bhavna.
Sir, good afternoon.
Good afternoon.
Sir, how accurate is hyperspectral data while studying climatic changes?
Hyperspectral data basically is providing, because it's a pixel level, very high resolution, pure pixel based analysis, image classification. And pixel level classification, if you want, like in a forest region, if you want that a forest patch has which type of forest patch is there, then you can go with the hyperspectral image classifiers. But main thing is that this much level of the information, if you get, then qualitative or quantitative aspect is good. But for the definitely the climate change situation, climate change approach is a very vast phenomena, and that can be used different type of data sets, not only the hyperspectral data set. But hyperspectral data set will provide you the quantitative assessment of the any natural resources.
Okay, sir. As you were saying that many species of birds are endangered and many are extinct. So, it's only climate change is responsible, or some other factors?
No, so not we cannot blame to the climate change only. Some of the our non-awareness about the particular things. Climate change, definitely it is going on, but everything we can blame on the climate change, that is not good. So many things, so many parameters are there. They are directly or indirectly influence the particular things. Our mentality is also responsible. What climate is cutting the trees? Why not we understand all these things? We should try to understand. Our knowledge may be non-disseminate to the grassroots persons. That's why the REDD Plus program was launched. So this is the thing.
Okay. Thank you, sir.
Welcome.
Raghu, you have raised your hand.
Yes, sir. Sir, I have a question. Good afternoon, sir.
Good afternoon.
Sir, for Landsat land cover classification, sir, you can suggest some best classification technique for this land cover?
Yeah, for land cover, Landsat data, I think you can use for the supervised classification, or you can go with a hybrid classification itself, in which the a priori knowledge, you can say the
you can say the
cluster
cluster
ISO data clustering you have to do,
data
as well
clustering you have to do, as well
as the training site you have to collect. This type of strategy, the hybrid classification approach is very good with the optical or the Landsat data set.
Okay, okay, sir. Thank you, sir.
Welcome.
Anyone still left with any questionnaire?
Sir, I have a question, sir. Sir, as we were talking about the green corridor that government of India is planning to put in a lot of money into it, into project, and you said ki we have natural barrier as Aravali, but in present scenario, like natural Aravali is like fast, it is getting degraded because of the human interventions. So what are the alternatives that we can provide? Because this will not stop until unless we have an alternative that has been provided to the human IA. So what alternatives that can be given to safeguard the Aravalis?
Alternate is that actually we have limited resources. Natural resources is very limited. We want to take the advantage of all these natural resources through the mining, through the biodiversity, through the any other like wood products, as in terms of the forest and so many other things. So that's why the human is greeding much more. So at first we should try to the sustainable development approach, SDGs approach. If you are cutting one tree, you have to produce more trees. That is a simple way. In that way, the overall solution is that the sustainable development, production, sustainable development things can be a better option to save our environment. Sustainability, that is also required. If you are require one thing, you have to produce more thing in place of this one. That is the solution.
Okay, sir. Thank you, sir.
Sir, there is another question from a lot of interactive session is there, so I cannot stop. Bhavneet, there is a question. Bhavneet, please.
Sir, good afternoon, sir.
Good afternoon.
Sir, which is better for post-forest fire assessment?
Post-forest fire assessment.
Yes, sir. Multispectral data or
hyperspectral
SAR data?
SAR data is much more suitable. Because SAR will provide the in-depth moisture content also, eliminate the things, and know any bidirectional reflectance is there. So that definitely the SAR data is much more capable, particularly the C-band data, radar set data you can use, or the ALOS Pulsar is also right now available. So free of cost, you can also use the L-band ALOS Pulsar data.
Sir, can we use Sentinel-1 data?
Sentinel-1 is also available, but I am familiar and I have used the ALOS Pulsar data. That's why it is best shown the result. But you can try. You can try, because try and try will be the best situation. You may get something. It is very good.
Okay, sir. Thank you so much, sir.
Welcome.
I hope that all the questions have been taken up. Still, I've missed any names. You're free. If not, then I'll proceed further. It seems that each and everyone has now completed it with their questionnaire. Now, on behalf of Center for Climate Change and Water Research, I thank Dr. Professor Lakshmi Kumar Sharma, sir, that from his busy schedule, he has given us the time in detail knowledge about all the aspects of environment, ranging from desertifications, forest fires, a man of knowledge working in the field of optical, microwave, hyperspectral, ready, all sustainable development goals. And we are very fortunate, sir, that you have blessed us with your valuable thoughts, insight, research, whatever you're doing to the society. And we pray that in coming years also, you will be coming over with more significant research in terms of environment. And we'll be following you, sir, regularly. and we hope that in future will be a partner of yours in terms of collaboration, research, supervision, and we need your blessings for our further growth, sir. Thanks a lot, sir.
Thank you so much, Dr. Suraj. And I must say that in that moment that Dr. Shruti and you itself creating a good knowledge hub and creating a good thing that the geospatial platforms is day by day increasing under your, you can say, enthusiasm. And I think that this type of activity should be gone, and frequent discussion is also required, because it's a limited community and we have to aware all these type of the environmental problems and all these things. You are doing a great job. Thank you so much for giving me this opportunity to interact the students and all these resources persons. Thank you so much.
Sir, thank you very much from the core of my heart, and thank you for enlightened with your knowledge to all the participants as well as the students of my center. Thank you very much, and we in future also we would like to seek your guidance so that we can grow in the field of geoinformatics. Thank you, sir.
Thank you so much.
Thank you, sir. So now we will end the session here, and we will again meet for the practical session at 2:10. Okay?
Okay, ma'am.
Okay then. Take your lunch. See you soon. Okay, bye.